Welcome, everyone. See, it looks like we're still getting a few folks in, connecting to audio. I'll go ahead and get started before our first session. So welcome, everyone, to day 2 of the 2021 EPA Region 9 and 10 Pollution Prevention Roundtable. The name and theme for this year is P2 West, Inspiration, Innovation, and Implementation. My name is Brittany Wendell. I'm the Associate Director of the Pollution Prevention Resource Center. And I want to acknowledge our nearly 30-member steering committee that has been meeting for nearly 8 months to put together a really awesome virtual event for you this year. And special thanks to ERG for providing logistical and technical support. So here's our lineup. Yellow column is today. First up, we have a session on PFAS source reduction. Then we'll have innovative approaches to green chemistry. We'll take a 30-minute break for lunch and then come back to hear about the emerging pollutant 6-PPD and pathway to decarbonization. And then we'll have similar format next Wednesday and Thursday with morning and afternoon sessions and a 30-minute lunch. And we had some really awesome sessions yesterday, and we have several great speakers going forward. So be sure to stick around and join us next week too. And just some brief housekeeping. I see that we have that in the chat as well from our Zoom support, but you can use the chat function to submit questions to the presenters. You'll all be able to mute and unmute yourselves. And that said, reminder that when you're unmuted, everyone can hear, so please stay muted when not speaking. The link that you use today is good for all remaining sessions, and presentations will be recorded and available soon. After the event, you will be redirected to a quick survey, so please take a few moments to give us your thoughts and feedback. And with that, I will hand it off to Michelle Gaither for our session on PFAS source reduction.
Okay, sound check, visual check. Thank you. Sorry if I'm a little muffled today. We had a potential exposure in the house. So my name is Michelle Gaither. I'm with PPRC, and I'm very excited for this session today. We are going to talk about addressing PFAS at the source, one at a time or all at once. And down. Okay. So these are our esteemed speakers for today, and I'm proud to introduce them. Dr. Simona Ballan is a senior environmental scientist at the California Department of Toxic Substances Control, where she implements the safer consumer products regulations and leads work on PFAS in consumer products. She's going to share with us California's strategy to regulate PFAS as a class, along with a bit about California's work relating to what they're finding in carpets, rugs, textiles, and leathers. And our second speaker is Carrie Foley, Master's of Public Health, works at Massachusetts Office of Technical Assistance, which we'll call OTA from henceforth. And they provide Massachusetts businesses with free confidential technical assistance for toxic use reduction. She manages communications, assists with outreach, policy development, and internal operations. Both of these women are highly knowledgeable on PFAS, so they'll share a lot of good information with us today. But Carrie will talk about working with the companies and utilities in PFAS source reduction and share some partnerships they formed with drinking water treatment facilities, and also a few strategic strategies that everyone should find useful to begin identifying PFAS upstream. I watched a webinar yesterday from the Toxics Free Future, and they had this graphic on. It was really enlightening, so I thought I would add it. just to give a big picture of the production, the manufacturing, the product use, and product disposal, and all of the places that are impacted by that and contaminated by it. And I thought, I also read this fascinating article in The Guardian a couple of weeks ago. So I wanted to suggest that we add this purple or the blue climate circle to this graphic for future use. And Simona will be presenting this, but I just wanted to give a quick little glimpse or big glimpse of releases, sources, and uses in manufacturing and industry. And then a couple of examples of commercial and service sector uses. We have airports using firefighting foam, auto repair, car wash, car dealerships, carpet cleaners, industrial laundries, granite stone countertop dealers, restaurant and food retailers, custodial, and some fluorinated refrigerants and solvents contain PFAS or will potentially break down to PFAS. So just wanted to give like an overall kind of notion of where we're finding all this and where it's going, where it's coming from, etc. And of course, disposal, in addition to reaching into the, the air and the water, it's also found in landfills, biosolids, incineration, and it's getting into our composting and recycled materials. And of course, there's always legacy contamination. So with that, I'm going to stop sharing and hand it over to Simona for her presentation. And then we will save Q&A for the end, if that works for everybody.
Sounds good. Thank you so much, Michelle. And thank you everybody for the invitation to speak here. It's really an honor to be here and talk to you about per and polyfluoroalkyl substances, or PFASs, and whether to address them one at a time or all at once. So as Michelle mentioned, I'm from the Safer Consumer Products program in the California Department of Toxic Substances Control, and we are taking a class approach there. So I'm going to show you a little bit about our approach. The exposure to PFASs is really complex, right? We have direct exposures from consumer products. We have exposures from manufacturing, from aqueous film forming foam. The exposures can be direct from contacting the products or indirect through environmental media. And when you add to the complexity of exposure, the fact that these chemicals are used in over 200 different applications, like this recent study by Kluge et al. Found, it gets really complicated, right? And so far, we've focused a lot on firefighting foam. I'm going to talk to you a bit about paper and packaging. There's a lot of work there. I'll also talk to you about what we're doing on carpets and rugs and on surface treatments for textile products. But there are a lot of other products that haven't yet been addressed as much, such as coatings and paints, plastic and rubber production, and electronic industry that, according to this recent study, may even use higher amounts of these chemicals. So there's definitely a lot to think about. And when you deal with something with so many uses and so many different class members and such complex exposure, it can feel kind of like this, right? It can feel a little bit overwhelming. And that's why, we think it makes sense to take a class approach. There's, of course, different ways of approaching chemical classes. There's the single chemical approach. There's the mixture approach. There's also the arrowhead approach that is used in, for instance, the Stockholm Convention, or some of the work that has been done under REACH, where the focus is on one chemical and all of its precursors, and that one chemical, like PFOA, is the arrowhead because everything else behind it is regulated because of the impacts of PFOA. But still, the only way to comprehensively address these chemicals is through a class approach. And I want to show you today how we were able to take a class approach in the Safer Consumer Products program. That in part is because our regulations are a little bit unique. we have a list of candidate chemicals that's a list of lists. It compiles 23 authoritative body lists that include chemicals either because of known toxicity or hazard traits, or because of their presence either in biomonitoring studies or in environmental monitoring studies. And what we do is we identify consumer products that contain one or more candidate chemicals that can either can lead to exposures and to adverse impacts. And if we identify this product chemical combination, we call those priority products. We list these priority products in the California Code of Regulations, and that triggers certain requirements from manufacturers, including an alternative analysis. So the manufacturers perform the alternatives analysis, comparing different alternatives and thinking whether the chemical and the function it provides is essential in the product. And based on this alternatives analysis and its results, we at DTSC then take a regulatory response, which can range from no action if none is needed to a ban and other things in between, like engineering controls or labeling requirements or things like that, again, depending on a case by case. For PFASs, we have the entire class on our candidate chemicals list because it was listed back in 2015 by Biomonitoring California, which is one of the 23 lists that make up our candidate chemicals list. I do want to mention that the Biomonitoring California definition is the one by Bucketall 2011. So basically anything that has a CN F2N+1 moiety in its molecule. And so when we identify priority products, we have two key questions that we have to answer. Are there potential exposures to a candidate chemical in the product anywhere in its life cycle? And can one or more of those exposures potentially contribute to or cause significant or widespread adverse impacts? And when we consider adverse impacts, I think what's unique and kind of innovative about the Safer Consumer Products regulations is that they consider a broad range of adverse impact factors. So those include the hazard traits or environmental or toxicological endpoints of the candidate chemical, but also of the degradation reaction or metabolism products of that chemical. It also includes aggregate effects, effects from exposures to the chemical used in other products besides the one that we're looking at, as well as cumulative effects with other chemicals that have similar hazard traits to the chemical we're researching. But in cases when there's less information available about the chemical, we can also use the physical chemical properties as proxies, as well as the environmental fate of the chemical and structural or mechanistic similarity with other chemicals with known hazard traits or toxicological endpoints. So for PFASs, there's very little information available for the majority of the members of the class, but we do know quite a bit about perfluoroalkyl acids, or at least a few perfluoroalkyl acids. And according to research that was done by the Organization for Economic Cooperation and Development, OECD, about 80% of PFASs are potential precursors to PFAS. So these PFAS that we know quite a bit about are metabolism or degradation products of most other PFASs. So when we looked at the hazard traits, there are some hazard traits that our regulations call exposure potential hazard traits. So those include for PFASs, environmental persistence, mobility in the environment, bioaccumulation, and lactation and transplacental transfer. And again, other than persistence, which is quite characteristic for the entire class, these other hazard traits were identified for some members of the class, but especially this one, lactation and transplacental transfer, as far as we know, it was determined for every PFAS that was tested for this property. We also identified a multitude of toxicological hazard traits for various PFASs, including environmental hazard traits like phytotoxicity and other toxicities that lead to wildlife developmental, reproductive, and survival impairment. But really the link between everything is that all of these PFASs that fall under our definition either are persistent themselves or they degrade or metabolize to other PFASs that are highly persistent. And this idea of persistence as a sufficient criterion for regulation is not new. This P-sufficient approach was proposed by others in the past. One fairly recent paper by Cousins et al. In 2019 says that if a chemical is highly persistent, its continuous release will lead to continuously increasing contamination and result in increasing probabilities of the occurrence of known and unknown effects. So in other words, even if we don't yet know all the potential adverse impacts of these chemicals, as long as they are highly persistent, they're continuously increasing levels, kind of like filling up a bathtub. Eventually that bathtub is going to overflow. So the levels might get to a point where adverse impacts will be observed in the future. And so that's why back in 2012, when the green chemistry hazard traits that we in the Safer Consumer Products use were put together, the Office of Environmental Health Hazard Assessment, who developed these hazard traits, they thought persistence needs to be a hazard trait right up there with all the other toxicological hazard traits. It's equally important because they said persistence is an inherent property of a chemical in the environment that results in increased exposure to the chemical and consequently potential for health risks. So that's why they believe it can appropriately be identified as a hazard trait. So if you want to read more about our approach, we published this paper in Environmental Health Perspectives where we explain in more detail what I presented today. But basically, the one criterion that the entire class shares is this high persistence. And for us, that was sufficient basis for regulating them, especially since there were a lot of other hazard traits displayed by certain members of the class that were well studied and that are degradation products of a lot of these chemicals. So in terms of the products, we first looked at carpets because we knew that they are a big percentage of, or a significant, I should say, percentage of the volume of waste in California. And there's potential for exposure to PFASs from carpets, not only during the use phase, but also at the end of life phase from their disposal and also from their recycling. So we listed carpets and rugs with PFASs as a priority product. Those regulations were finalized in July 1st of this year. And so after that, manufacturers had until August 30th to notify us whether they manufacture and sell this product in California. So basically, if they sell carpets and rugs with PFASs in California, and we have received no notifications. So basically what this means is that there shouldn't be any carpets and rugs containing PFASs manufactured as of July 1st, 2021, and still sold on the California market. We will verify this through compliance activities. So we're planning some testing, and if we find PFAS is still in products, we will undergo enforcement activities. Currently, we are in the process of rulemaking to list treatments for use on converted textiles or leathers. And these treatments are some call them aftermarket treatments. So they're the sprays or liquid solutions that can be used to clean products such as carpets, rugs, furniture, clothing, shoes, anything that's made of leather or textiles. We are currently accepting public comments on our proposed rulemaking until November 8th. And we also have this document where we explain the basis for why we're proposing to regulate this priority product. But here, the potential exposures are also directly to the user because these are often sprays that can lead to inhalation exposures. And so after we finish listing this priority product, the alternatives analysis process kicks in. And through that process, if manufacturers are still using PFASs in these treatments sold on California market, they will have to answer key questions such as, are PFASs necessary? Is there a safer alternative? And what are the trade-offs of substituting them? And we do have a guide to walk manufacturers through this process. And so as I mentioned before, based on the alternatives analysis, we take a regulatory response, which can range from anywhere from no response to end of life. if to a ban or a sales restriction. But if there are no safe alternatives identified in the process, then we can request funding for research into green chemistry alternatives or green engineering solutions. We also looked at food packaging with PFAS, specifically food packaging made of plant fiber materials. But we have stopped this process because actually on October 5th, Governor Newsom signed AB 1200, which bans the distribution and sale of these products in California starting January 1st, 2023. The bill, however, it defines the class of PFASs more broadly than our regulations. It actually uses this definition of any fluorinated organic chemicals containing at least one fully fluorinated carbon atom. And it covers anything that's intentionally added by the manufacturer or that is present in a product or component at or above 100 parts per million total organic fluorine. So I want to end by tackling a big question, especially when you talk about a class-based regulation. How can you even tell if products contain PFASs? Currently, there are no methods that can detect all PFASs. And so really the only thing that we have are total fluorine methods or total organic fluorine methods. That's basically the only way to confirm the absence of any PFAS in a product. If you don't detect any fluorine in there, then obviously there's not going to be any PFAS. And these methods are also relatively fast and inexpensive, but they are not specific to PFASs, so they could capture other fluorinated chemicals that don't meet the PFAS definition or even inorganic fluorine. So there are other targeted analysis methods that can confirm the presence of PFASs, but they cannot detect the PFASs that are intentionally added, at least in the products that we've looked at. They can only detect impurities or degradation products of these intentionally added PFASs. There's a total oxidizable precursor assay, which can convert some of these PFASs into the ones that can be measured through targeted analysis. So this can also be helpful, but it's much more difficult and expensive, and it still doesn't capture all PFASs. And lastly, there's non-targeted analysis, which can right now detect up to over 2,000 PFASs, and it can confirm the presence of PFASs, but it's difficult, expensive, and again, it can't capture everything. And as far as I know right now, it cannot detect polymers. So we don't have a good method to detect the presence of any PFAS in there, but just to confirm the absence of PFASs and to detect the presence of certain PFASs that may be fairly common in these products. So when it comes to these total fluorine methods, there's a few that we've looked at. PIGI, some of you may be familiar with this. It's an academic method for now. It hasn't been made commercially available, but it's very fast and inexpensive. I believe they can test up to 250 samples a day, and it's non-destructive. And its detection limit is not very low, but if you're looking only at intentional addition, then that detection limit is sufficient. The commercially available method is combustion ion chromatography, which has even lower detection limits, going down to 0.1 parts per million. We've also looked into XRF and LIBS methods, which can be handheld, portable methods. So you could, in theory, take one of these into a store, but unfortunately, they may have high detection limits. We're still trying to figure out if these could work for consumer products. So yeah, there's a lot to figure out there, but if you're interested, I think we're happy to keep you up to date in terms of what we find. So, what's next? As I mentioned, we're only just scratching the surface in terms of products, so we're not sure where we're going to move next. But there's definitely a lot to still explore when it comes to the use of PFASs in consumer products. So if you're interested in staying in touch, and this is my contact information, you can join our e-list here to learn of our current activities, or check out our webpage. And CalSafer is our information portal where we post all the materials that we get from our stakeholders through these public comment periods. And finally, we have a couple fun videos about PFASs and our class approach, so feel free to check them out if you wish. And with that, I'd like to thank you for your attention, and I'm happy to take questions.
I think we're going to do questions at the very end.
Okay.
And we have one or two in the chat already. Thank you. That was super enlightening and interesting. Now let's move on to Caradwyn, and I will pop a bunch of those links that Simona just had on screen into the chat as well.
Great, thanks. Can everybody see my screen there, Michelle?
Yes.
Are we sharing? Okay. Great. Well, welcome everyone, and thank you, Simona. That was a fantastic presentation, and thank you, Michelle, for the introductions up front. I'm here today to talk about some boots on the ground P2 efforts that we've been working on here in Massachusetts around PFAS, and some of what we've learned along the way about partnering with companies, with other agencies, and with utilities. As Simona was kind of alluding to at the end there, there's a lot of sort of what's next around identifying these sources and figuring out how do we target these P2 efforts. So I'd like to talk a little about that. So I will share what the Office of Technical Assistance does in a minute, but I need to give a bit of background on our context here in Massachusetts first. So we have a state law called the Toxics Use Reduction Act, which was passed in 1989. And this law applies to businesses operating in the state that fall under specific standard industrial classification codes with more than 10 employees that are using over a reportable threshold of listed toxic or hazardous substances. And there are currently about 400 companies that fall under the law's requirements. And those companies are required to annually report to the Massachusetts Department of Environmental Protection about the listed toxic substances they're using. They have to pay a fee, and every 2 years they have to undertake toxics use reduction planning and then submit a summary of the plan that they do to Mass DEP. And it's important to note that TURA does not prohibit the use of any chemicals. TURA reporting is there for right to know purposes, and companies aren't compelled to reduce their use of toxics, but they're compelled to make a good faith effort to consider how they could. And the hope of the legislature was that if companies had to do this planning every 2 years anyway, many of them would opt to do the right thing. And that has been borne out. Toxics use under TURA has fallen by about 40% in the state since the law was adopted. So TURA is co-implemented by 3 bodies. Mass DEP, as I mentioned, is the compliance and enforcement arm. The law also established the Toxics Use Reduction Institute, which operates out of UMass Lowell, which conducts research and provides industries and communities with grants and other assistance to support the implementation of TUR activities. And it established my agency, the Office of Technical Assistance, which exists to provide companies with confidential technical support so that they can pursue toxics use reduction activities. So a little more about OTA. I mentioned that our services are fully confidential. They are also free. The fees that TURA filers pay every year are what support our work. And we work with companies to help them identify opportunities for toxics use reduction and for resource conservation as well. And we help them implement options once they've been identified. And while our staff can and do support with things like water conservation or energy conservation, our bread and butter and the reason we exist, the reason TURA exists is to promote source reduction, to minimize the use of toxics in the state with the end goal of really protecting worker health and protecting public health in the community and environmental protection as well. So we're here today to talk about P2 for PFAS. And I know many of you are quite familiar with these substances already. Simona gave us a great primer on their hazards and characteristics and the importance of addressing them as a class. And we're on the cusp of adding a category for PFAS to the TURA list of toxic or hazardous substances, the list of substances that need to be reported on. An amendment to our regulations is pending. Our public comment period just ended like on Friday, and we anticipate filing the final regs at the end of next month, and then they should be promulgated for the new year. So they'd be effective January 1st. Companies would track their use throughout 2022, and then the first round of reports that include this category would be due in July 2023. And I'll just flag here that our Science Advisory Board looked at perfluoroalkyl compounds with at least 3 fully fluorinated carbons, or perfluoroalkyl ethers with at least 2. So we're not all the way down to 1 fully fluorinated carbon for this category, but just wanted to kind of put that out there for the moment. So as this regulation is pending, we know that some companies are facing some impediments in addressing PFAS reduction. And some of the ones we hear about commonly, one of the big ones is lack of awareness. Even companies that don't want to be using PFAS don't always know that they are. PFAS are often not included in SDSs that companies receive from their suppliers. Manufacturers of the products that companies are using often withhold information about PFAS ingredients as proprietary, and suppliers also aren't all that cooperative in helping companies track down detailed product information. And companies might also be using PFAS contaminated feedstock, whether that's recycled paper or tainted well water. So it can be really challenging for companies to figure out whether they are using PFAS in the first place. We know that regrettable substitution can be an issue. That's something that we're hoping to address going forward by adopting this class-based approach. But over the years, a lot of companies have traded out C8 for 6 or 4 chains, and even these shorter chain chemicals are still highly persistent. Concerns about liability can get in the way. There's certainly no incentive for a company to test for PFAS right now if they don't know it's there. And again, with the incoming feedstock issue, it could be that the company that wants to be the good citizen that is testing for it and finds out that there's a problem might end up subject to misplaced liability if they find out about it, even if they're not the source. And over the years, there's also been limited regulatory pressure to do anything about this. One of the drivers that we have here in Massachusetts is that for companies to renew their wastewater discharge permits, over the next few years, those permit renewals are going to start requiring PFAS testing. Now, that's a tool that we can use to overcome some of the disincentive to test for it, but policy change and implementation are slow, and the development of suitable testing methods for all these media has taken so much work and time. And we're excited to see the progress EPA has been making around that, but it takes a while to kind of roll that out to companies. So our guiding lens in our toxic use reduction work is really the protection of worker health and public health. And for any of you who have a public health background, you might recognize our friend John Snow here, who is widely regarded as the father of epidemiology. So during the London cholera epidemic of 1848, working upstream to identify the sources of cholera infections led Snow to conclude that it was being spread through contaminated water. And today, we're looking at a population where we know we have incredibly widespread exposure to PFAS, particularly through drinking water. And we're trying to work upstream to find those sources. So John Snow was engaged in what we call boot leather epidemiology, going door to door, talking with residents, figuring out where their water was coming from. And, tracing these cases, it turned out that ground zero for Snow's cholera epidemic was the Broad Street water pump. And this isn't so different from what we're trying to do now. We want to work our way upstream so that we can identify sources of PFAS and then hopefully, reduce or eliminate them. So OTA has undertaken a new public health collaboration. We want to try to identify potential PFAS users so that we can offer them targeted P2 assistance. And this takes a lot of hands on deck. We've been collaborating with other Massachusetts state agencies, with the Massachusetts Water Resources Authority, and with local wastewater treatment facilities. And it's also meant working across state borders with our friends here at PPRC and EPA and states like Washington and Michigan that are doing great work to identify PFAS sources. So our first step was to narrow down some industries where PFAS are commonly used. So our staff and some very skilled interns that were assisting us have spent a lot of time acquainting themselves with different manufacturing applications for PFAS. And so we started, reviewing those general industries, but then also cross-referencing that with who's in our state, who are the manufacturers active in Massachusetts who might fall into these categories. So Mass DEP had flagged some specific drinking water protection areas where we were going to want to prioritize our outreach efforts. And with the help of our EPA Regional Pretreatment Coordinator, along with Mass DEP and MWRA, we set up lists of companies upstream from local wastewater treatment facilities who belonged to these industries that we were interested in looking at a little more closely. And the goal here is for OTA to reach out to these companies to get in the door and really be able to offer them some targeted assistance. So once we had our outreach list, the next step was referral. And OTA has done outreach a lot of different ways over the years. And as you can imagine, it can be challenging for a government agency to cold call a company and truthfully say, we're offering you free confidential pollution prevention assistance. And if you're in violation of something, we won't get you in trouble with Mass DEP. That is 100% true, but it's an awfully tough sell. So another challenge is that typically, the way we get in the door is by following up after a company has received a notice of non-compliance from Mass DEP when they have an issue they need to address. So it's hard to make clear to companies that the information there is only allowed to go one way. DEP can tell OTA that someone needs our help, but we can't legally tell DEP anything about providing assistance to a company. Now with PFAS, it's not a compliance situation yet, but we're trying to do something kind of delicate here. This is an emerging area of concern for companies. They're sensitive about pending regulation. They're sensitive about the prospect of liability. And we're also really asking for their help in a way, because we need these companies to help us learn where in the state the PFAS are coming from. So we need to sort of finesse the relationship a little bit and get in the door in a way that's designed to build trust. And the best way to do that in our experience is by referral. So Mass DEP was arranging introductions between OTA and the local wastewater treatment facilities. And then those facilities would do some initial outreach to the companies who were their neighbors. They had existing relationships to leverage there. So we use that to kind of soften the ground and let companies know that we were available. And then we would do outreach to those companies. And several of the companies that we reached out to ended up making use of a supplier notification letter that we put together that was really meant for companies to contact suppliers about PFAS that has been listed under the Toxics Release Inventory. We're also going to be making a new version of that letter to reflect this larger PFAS category that we're about to list. But we wanted to be able to give companies a way to start that conversation with their suppliers and really start, at least like making the effort to find that out if there are PFAS in incoming products. Other companies that we've talked to are looking into wastewater testing for PFAS. Some have already begun conducting it, and a few have expressed interest in receiving in-person technical assistance visits from OTA. I think we've had 3 site visits with companies so far. And how our outreach goes has really depended a lot on the existing relationship between the company and the wastewater treatment facility that did the referral for us. So if they're in regular contact, if there was good contact information there that we could use, if there's a good relationship, that helps our outreach go more smoothly. Whereas if there's a little less engagement, it can be more challenging. So I want to talk a little bit more about some of the services that we have been developing to offer for companies. Because the first step really is just figuring out if they're using PFAS at all. I talked a minute ago about that supplier notification template and about looking into testing. we also started developing these assessment tools, basically industry-specific surveys to see if there were any red flags for specific applications where we'd expect to see PFAS. And I want to just pause for a second to acknowledge the great work that Michigan DEQ has done on identifying potential and probable PFAS sources. We borrowed some of our content for these assessments from some of their questionnaires, which were incredibly helpful. So we've identified 4 industries so far where we felt like we had enough information to do this. And we've already drafted surveys for the paper and metal finishing industries and are preparing to start conducting those soon. And then looking ahead, we're also planning to develop them for manufacturers of surface coatings and of textiles, especially like performance textiles. So when we administer a survey, OTA staff will walk the company through each question. We're also hoping to develop a self-serve tool, but we're not quite there yet. But we're asking participating companies as well if they have a list of cast numbers to share that with us so that we can cross-reference it with existing lists and see if we can, if we kind of trip any notices that there are PFAS products containing some of those, or products known to contain PFAS. And if companies let us know what products they're using, we can do some legwork, and our colleagues at TURI can assist with some laboratory work to see if those products contain PFAS. We're also going to encourage companies to allow us to add the names of products they're using to an informational list that we're developing with TURI. And the hope for that is that once we can develop a list of products that are known to contain PFAS, we can make that publicly available and then offer it up to companies so that they can really make informed purchasing decisions. And this might also help highlight places where safer alternatives are available and where alternatives might still need to be identified. So we really want to be able to make sure that our companies here in Massachusetts are able to make decisions that prioritize P2 and that are really promoting the health of their communities and keeping their workers safe. And we think that this kind of interstate collaboration could be a good model for other technical assistance providers too. So I hope this has been helpful. We're happy to answer any questions you might have. My contact information is here, but I will stop there. Thank you.
Thank you so much, Kara. All right, I'm waiting for questions to come in, but in the meantime, I have a question about if either of you know, I was reading about the Alabama PFAS manufacturing plant recently. It's called Daikin, I believe, and they're I think they coat fast food packaging. And the article says it pumps out loads of this banned substance into the rivers and such. Anyway, I'm wondering if there are actually, I don't know if you know this company in particular, but are they actually producing the PFAS itself, or whether they're just using the PFAS to coat it? But if they are, where are they getting the PFAS from? I think most of it's, a lot of it's still made in China, or I guess my question is, are there PFAS manufacturing plants in the US?
Yes, there are manufacturing plants in the US, and I believe the one that you were talking about was Daikin, right?
Yes.
Daikin is one of the PFAS manufacturers, and they do make those formulations for use in food packaging. So if you look at the food contact notifications that are authorized by US FDA for use in food contact materials, Daikin is one of the companies that has authorized food contact chemicals that can be used and that are PFAS based. However, they do have a voluntary agreement with FDA to phase out their PFAS formulations over the next, I guess it was a 3-year agreement. I think we're kind of 1 year into it. So yeah, they will be phasing out their products. And I don't know if they intend to replace those with other PFAS formulations, or if they're completely moving away from the PFAS manufacturing specifically for food packaging. But I know they manufacture PFAS for a lot of other uses as well.
Thank you. is there any opportunity to work with, I don't know how many other PFAS manufacturing plants are in the US? Is there any opportunity for technical assistance providers to work with them directly versus the users of the PFAS in the next rendition of a product?
I mean, my thought about that, and Simona, feel free to layer in, is that, you know, if the most effective lever might be to reduce demand. And, you know, if there is continued demand for PFAS, you know, as a component in products or as a raw material, then those manufacturers who are originating it, who are really the kind of furthest upstream source, will continue making it. But if the companies that they are supplying can find safer alternatives and are relying on those instead, you know, I think that would be our hope. And, you know, we have, I'm sure people are, you know, generally acquainted with the, you know, kind of essential use doctrine, and you know, attempting to curb these applications of PFAS for which there might be safer alternatives that aren't for, you know, strictly life-saving needs or other kind of critical essential uses.
Okay. We have a question from Cindy Riles, and it's for Caradron. When testing products to make a publicly available list of PFAS containing products, will you also publish the products tested that do not contain PFAS?
Yeah, I think we also hope to be able to share some information about, you know, identified safer alternatives. Certainly one of the things that our technical assistance providers do is try to work with companies to direct them toward substances that they, you know, products that they know to be, to not contain whatever chemical of concern it is that the company is attempting to reduce. And certainly that, you know, that'll be our approach for this as well. So we will make resources available as we have them.
And Cindy, you might be interested in reading the Washington Department of Ecology's recent alternatives assessment on food packaging. That might shed a little light as well. Question from Miguel wrote us: is there already, legislatively speaking, any directive to include PFAS as ingredients in chemicals in general?
So is this
Miguel's in California, so I don't know if that's maybe a Simona question.
So I'm guessing that the question refers to ingredients in products, like in consumer products. I don't know. I'm actually not aware of any direction from the legislature to move in that direction. I know there was there's a requirement for, you know, ingredient disclosure in cleaning products in general. So if there are any PFASs included in there, they would have to be disclosed as well. Same with personal care products, but in general, I'm not aware of any push to require disclosure, except for this recent bill that got passed and that I mentioned, AB 1200. So I only talked about the fact that it banned fiber-based food packaging that contains PFASs, but it also has an ingredient disclosure requirement for cookware. So for cookware, that bill requires labeling if the cookware contains any chemical that's on our candidate chemicals list. So not just PFASs, but anything that's on the candidate chemicals list that my department maintains. And that list right now has over 3,200 entries. Some of those are chemical classes like PFASs. So anything that's on that list that would be in cookware, in either the handle or the part of the cookware that's in contact with food, that would have to be disclosed. But I'm not aware of other efforts.
Caradron, I did not mean to cut you off. Did you?
No,
okay.
That's fine. It looks like Miguel has his hand raised if he wants to clarify a question or anything.
Absolutely.
Yeah.
And Jen Jackson might have some input on this as well. So both of you, please feel free to to unmute and chime in.
I think I misunderstood Miguel's question. I thought he was asking, is it required anywhere to use PFAS? And the only thing I could think of was firefighting foam used at airports. But now I think I understand what your question is, where it's required to disclose the ingredients. Yeah.
Yes, this is Miguel. Can you hear me?
Yes, we can hear you.
Okay, yes, just to clarify, you know how we rely on the SDS now on the safety data sheet to verify the ingredients of any specific chemicals or proprietary chemicals. So now with this PFAS, are we, my question was, at the federal level, is there any directives as to for producers of these chemicals to include or disclose PFAS as actual ingredients in these chemicals? That's basically my question, and that applies to the across US.
Yeah, that's a great question. And unfortunately, I don't know the answer. I haven't heard about that, but if any of the other attendees have information about that, please let us know.
Yeah, I mean, there are for the PFAS that are listed under the toxics release inventory, which is a narrow subset of them. If companies reach out to their suppliers to notify them that they if companies can request information from their suppliers about TRI listed substances, and suppliers have to notify their customers of any listed substances that are over the de minimis level, which I think for the 172 PFAS, the de minimis is 1%. I think it's lower for PFOA. So there is a federal requirement for those substances, but a lot of those 172, I think there's 175 now actually, because 3 more were added earlier this year. For those PRI listed PFAS, there is a requirement that suppliers tell their companies if they're present in products, but that's a pretty narrow subset, and a lot of those specific compounds have been phased out of commercial use. So for a lot of the ones that we're still concerned about that are inactive commercial use, there aren't any requirements that I'm aware of that would apply to them. I don't know if anyone has anything to add to that.
Okay, guess not. Thank you both. I have let's finish one final question, again from Miguel. California has some approved fume suppressants for hexchrome plating operations that are non-PFAS. And he's wondering if any other states also have approved non-PFAS fume suppressants.
So I don't know about states, but I do know that that the EPA recommended some alternative fume suppressants for hexchrome plating to replace PFOA containing fume suppressants. That's the extent of my knowledge about this. I don't know what action has taken place at the state level, but I do know at least that there are some EPA recommended alternatives.
Well, thank you again, and thank you to Jen Jackson for my co-conspirator in planning the session, and thanks for all of the technical support along the way, and I guess that concludes our session. So I'll hand it back over to Brittany.
Great, thank you, Michelle, and thank you, Caradwin and Simona. Excellent session. So next up, we have Innovative Approaches to Green Chemistry, which will be facilitated by John Katz. So John, whenever you're ready.
I am ready.
Take it away.
Thank you. Thanks, everybody, and welcome. This session is going to touch on a few aspects of green chemistry, slightly different, and have some great speakers looking at both the chemical alternatives as well as innovative programs to promote greener chemistry. And as just to make sure we're all kind of on the same page, I want to just give a quick introduction to what we're doing here at EPA around green chemistry and context around the Safer Choice program, and then I'll turn it over to our speakers and introduce them. I'll introduce them right now. Well, I'll introduce them as they come on. So let me just share my screen quickly. Okay. All right. So just very quickly, this will be very quick. I think many of you are aware of what is green chemistry, but just so we're all on the same page, it's really the design of chemical products and processes that reduce the use or generation of hazardous substances. And almost all the definitions and practical applications of green chemistry really focus on life cycle, not just the immediate toxicity, but both the production of it and end of life. And the real focus is on source reduction, should be. At EPA, we really promote green chemistry in three different buckets. One is the Safer Choice Labeling Program, which we'll hear about more from our speakers, Brittany and Lisa Cox. And we also have the Green Chemistry Challenge Awards, and we also do fund research and development into green chemistry, both internally in our Office of Research and Development, and we also have external grants on specific aspects of green chemistry. For those of you who may not know about Safer Choice, I'll just a couple quick slides. It's basically an EPA eco-label for safer chemical products. It's based on a very rigorous and public process for certification. So any products that get the label must meet our Safer Choice standard, which is evaluating a product both at the ingredient level. Every single ingredient in the product must be disclosed to the profilers, the third-party profilers who review it against our criteria. And then we review it as well. And then they also have to reveal, it's also evaluated against at a product level, looking not just at chemical level individual effects, but also additive or synergistic effects, as well as the product has to perform. There are requirements around packaging, and they also have to disclose to the public all the main ingredients in the products. A product that chooses to get certified is under a partnership agreement with EPA that's good for 3 years, and then any product has to be recertified, and they undergo annual audits. And right now we have about 2,000 products on the EPA Safer Choice list from about 500 manufacturers. Many of those are focused on the institutional market and industrial market. About 600 of those are retail products for the average consumer. And that is a wide range, laundry, cleaning products, detergents, all-purpose cleaners, degreasers. We also have a number of specialty chemicals like floor care, de-icers, holding tank treatments, that kind of thing. For those of you, you'll hear in our presentation in just a minute, is there are real opportunities for the pollution prevention community to leverage the EPA label and also partner with it. The way we look at it is building on the demand side, working with purchasers at all different levels to encourage them to use the Safer Choice and other eco-labels, credible eco-labels for cleaning products, whether it's through green business programs, putting that on their checklist, or as part of your site assessments of facilities that do significant cleaning. Lots of opportunities to promote the Safer Choice label. You can also help on the supply side, and that's what you'll hear a little bit from our friends in Washington and Oregon, helping recruit companies and manufacturers and helping them through the Safer Choice program. I also just want to touch briefly, we do also have the Green Chemistry Challenge Awards. These are EPA's awards awarded in concert with the American Chemical Society for companies and also researchers that are finding new and innovative ways to design chemistries that are greener. These are the key areas here. And just, I'm not going to go through this in any detail, but just if anybody is interested, or you know of companies, or you know of people working in the green chemistry space, really encourage them to look into the Green Chemistry Challenge Awards, because we're always looking for innovative ideas and to recognize those and elevate them and hopefully move them towards commercialization. So with that, as an overview, I want to introduce our first set of speakers. I think many of you already know Brittany, but Brittany Wendell and Lisa Cox. Brittany is the Associate Director of PPRC and has been our host this morning and yesterday morning. And she directs the organization's projects in Oregon, including the State EcoBiz Certification Program and the quarterly P2 outreach meetings. She will be presenting with Lisa Cox, who is a nationally recognized environmental professional who works at Oregon DEQ as a senior toxics reduction analyst. And she implements projects that protect human health and the environment by reducing the use of toxic chemicals through many partnerships with businesses, including supporting the Safer Choice program. So with that, I will turn it over to Brittany and Lisa. And I will stop my share. Oh,
thank you, John. Let's see. All right. Yeah, so thank you for having us. So Lisa and I will be talking about projects in Oregon that support the Safer Choice program and increased use and availability of less toxic Safer Choice certified products. So Lisa will start us off with Oregon's statewide internship program.
Hello, everyone. Lisa Cox here. I'm coming to you from Portland, Oregon. And thank you, Brittany and John, for the introduction and for inviting us here today. I'm excited to see everyone and hear such informative talks. It's been really great. So I run the Oregon Applied Sustainability Experience Internship Program that places students with businesses for 10 weeks in the summer to conduct pollution prevention and sustainability research. You'll be hearing more about that next week if you attend that session. And we have a great program because we have so many amazing partners that have been made possible through the Pollution Prevention Grant Program run by the EPA. Our major partner includes the Oregon Sea Grant to administer the program. And in addition, we have 40 other organizations, nonprofits, and host businesses who support the program through mentorship, outreach, training, and more. We focus on pollution prevention, as we all do here. That includes green chemistry, sustainable materials management, and those are also in line with Oregon's 2050 vision and framework for action. The paid interns are on site for 10 weeks with Oregon businesses to, again, conduct research on a project that's identified by a business. And since 2017, we've had many types of businesses with a variety of projects that include conducting a preliminary life cycle assessments on packaging, to water conservation, to preventing water pollution, reducing energy, preventing food waste, reducing hazardous and solid waste at their businesses, and much more. So on our fourth year, we decided to focus a little bit more on green chemistry and endeavor to integrate the Safer Choice program into the OASIS program. We believed that the intern could assist a business in obtaining the Safer Choice certification for a product, research possibly chemical substitutions, and identify if the product could be reformulated. So we conducted very targeted outreach, and luckily we found 2 businesses to host an intern. One included the Oregon Soap Company, located in Portland, who makes soap, obviously. And then Good Clean Love, located in Eugene, Oregon, who makes personal care products. We also were able to get Defunctify on board. They make detergents and stain removers, and Defunctify has made or already certified many Safer Choice products and planned on going through the certification process again for a new product. So with them on board, they offered some mentorship and guidance for the other businesses, which was a great find. So this is what we learned. New product categories. I mean, it's all here. It's a lot of text, so I don't expect to have you read it all, but we just learned a lot. And the new product category for the personal care product had some obstacles that we had to get through with the company and EPA. And the other pieces are really small businesses. All of these businesses were under 25 people total. They just don't have a lot of capacity for this kind of work. Educating their own staff and then moving through the process is pretty difficult. We do believe that an auto-approved ingredients would make the process significantly easier, and having a national approved list to point to this would be very critical. So we continue to learn lessons, and some of the other ones in terms of costs is that there are a wide variety of costs that are given to the company from each of the different consultants or people who are looking to get the products certified or the chemicals certified. And the time frame can really change depending on who you get to work with and the EPA staff that are available. And again, it can be a little bit complicated for the small businesses. For Good Clean Love, they have about 18 employees, and they ultimately decided not to go forward with the certification. The estimated cost for the 3-year certification was over $200,000, and that included the evaluation of 6 products by one of the EPA's third-party profilers. They also had to do, or were asked to do, a consumer perception survey to address some of the labeling concerns for the product, and that was going to cost about $8,500. The requirement for the survey was a surprise to the company, and it became a bit of a point of irritation with them and the EPA. So we had to kind of work through some of those obstacles, and we're continuing to work with them this coming year, we hope. Some of the obstacles that were encountered by the soap company with 24 employees. They initially wanted to certify all 60 of their products, and the initial cost estimate from the EPA profiler was $120,000 and was just at that time out of their budget. So they decided to focus on one product, an unscented green alternative restroom liquid soap. And the evaluation, the estimates for that evaluation ranged from about $5,000 to $24,000. And then with the pandemic disruption, they actually were making a lot of soap, and they didn't have a lot of resources to move into this new space. But the owner of the company is super supportive of the Safer Choice program. He did not know about it before we started to partner with him. So in the long run, it's been a really great partnership and win. So we're excited to continue that relationship. Some of the other obstacles that we've learned about, especially through Defunctify, who is a veteran of the process, is that the time from submission until review and completion has doubled from 12 to 24 weeks. And we have been working on some of these obstacles at a national level, led by Jenn Jackson, to help EPA realize some of these areas where we could do better. And I think we've made a lot of progress in the last year to help them prioritize the Safer Choice program. So in all of this, we're still very excited, and we're moving on to a phase 2 pilot that Brittany's going to talk a little bit more about, excuse me, because they are a major partner in delivering this program that has been funded again by the EPA and also our DEQ program, materials management. So Brittany's going to talk a little bit more about that and our plans for the upcoming year.
Thank you, Lisa. Yeah, so as Lisa mentioned, these exploratory intern projects really gave us a solid base to identify the next steps in developing a more robust program to assist some of these smaller businesses in certifying their products. So as she mentioned, we sought some additional funding through the EPA Healthy, Resilient, and Sustainable Communities Grant Program. And we're currently working to roll out a new program, taking all of these lessons learned with us. So for the first step, we are building on information gained from the OAC internship projects that were focused on safer choice, and are developing a guidance manual that includes a step-by-step outline of the Safer Choice product certification process. So this manual will take into account business considerations, navigating some of these barriers that Lisa mentioned, and identifying incentives for certifying. We also have a business application and program guidelines. So by asking the businesses to apply and commit to the program guidelines, we are hoping to gain strong business partners that will see, these efforts through to the final certification. And Lisa has successfully used this method in her internship program. So we're hopeful. In the next couple months, we will be recruiting product manufacturers to apply and commit to hosting a fellow or a dedicated associate who will guide and assist staff on the certification process. This fellow will compile product ingredients, find potential alternative chemical ingredients if necessary. They'll also be preparing safer choice application documents and obtaining chemical assessment quotes and sharing these options with the host business. So they'll work with each host business for 2 full days per week over 3 months. And this photo is one of our awesome interns, Angel, who worked with Oregon Soap Company on their Safer Choice certification work. So as mentioned, and no surprises here, one barrier for businesses that we have identified is the costs associated with third-party chemical assessments. So the base fees for these product assessments are around $5,000, and some products, as Lisa mentioned, require additional review and more in-depth research, which can significantly add to these base fees. So this can come about if the product has a functional use that's not currently defined by Safer Choice, or if there are undefined compounds such as fragrances, which may contain 25 or more different ingredients. So to help remove some of this barrier, host businesses will be offered a financial incentive to cover base fees associated with third-party chemical assessments. And we're really aiming to create an easily replicable program with guiding documents that can be shared with and implemented by other technical assistance providers and communities across the United States. So stay tuned, and please feel free to contact either Lisa or me if you are interested in implementing some similar efforts in your area. And outside of this project, where we're working with product manufacturers, PPRC and DEQ have been delivering trainings to businesses on identifying third-party certified less toxic cleaners, including Safer Choice product substitutions, and how to actually find and purchase these safer choice products, which sometimes can be difficult. So we've been focusing on businesses that are BIPOC owned and operated, as well as the cleaning sector. So our overall aim is to grow awareness and build a higher demand for safer choice certified products in the region, while building this new program to streamline the safer choice certification process for manufacturers. So that is it for us. I don't know if we want to take questions now, John, or later, but please feel free to reach out and get in touch with us. So thank you.
Sure, we have time. Let's take a few questions. If there are any, there are a few in the chat, which one that I put in there, but if anybody else wants to put their question in chat, the one I put in, if you can't see chat, I was curious for Good Clean Love. I was surprised to hear that the evaluation cost was going to be, what do you say, something like $150,000 to $200,000.
$230,000. And I have the list how many chemicals it is, but I was just looking that up. I don't remember.
Right, and I just that's do you have a sense of what drives that cost? Is it the base fee? Is it the fact that it's they're complex chemical formulations, so there's a lot of digging that's required?
From Good Clean Love, they are certified by several other I guess certification organizations. So their chemicals, I think, are pretty, basic, I guess. And they don't have like fragrances, things like that would maybe make it more complicated. But it seemed like it was because the evaluators didn't have those chemicals already in their databases.
Yeah.
And it was just one evaluator. So keeping in mind, and I wrote this in the chat, that different of those three companies, because one has been used more, they already have a very large database, which makes the costs lower. And it's a bit tricky, I think, in that way, because, it's like, well, I know we're trying to have three and that helps, things. But in the end, it seems like one might be used more because they already have so many in their database. So it's, and the intern, I'm sure they did not get evaluations from all three assessors. So that's the other thing that we will likely change in this next round.
Great. And there was another question in the chat, which I'll put out there. Maybe everybody wants to hear, is to you, Lisa, curious about how the businesses are looking at the value proposition of certification, given that the price is so high. If they didn't think the cost was low enough for the investment, maybe they didn't think that people cared about the certification enough. So what's the feedback you're getting on the business space for certification?
The Good Clean Love, they absolutely did believe in the label and that their customers would believe in the label. But because this is a personal lubricant and the label safer choice was, we were very confused on whether the consumer may think that would be something that would protect them from STDs. So it wasn't that the business didn't believe, or I think wasn't ready for the financial investment. It was because of that extra survey that they were going to have to do to their consumers that just kind of like stopped up the process. So I think that they believed in it. With the soap company, they have other certifications like organic certification that's like $8,000 for the entire, like a 5-year period. So I think it was just a sticker shock at that moment that they were just not prepared for. And again, these are all businesses that have under 25 people. And it was during COVID, so there were a lot of changes that they just, I think, couldn't absorb at that time. And keeping in mind that these two businesses had never even heard of safer choice. So there was a lot of education that we were providing as well. So I don't know all of the reasons, but those are some that I have gathered.
Great.
And yes, we really want to share absolutely the other questions. The manual that we will developing will be, intended for, a national audience. That I think the hope is to provide something that's, repeatable in other places, just like the regular pollution prevention internship programs that have occurred across the nation.
And there was another question in that. Are you coordinating with Safer Choice on the development of that? I know they have done some work internally, on kind of marketing it, primarily marketing it to purchasers, but you're really shining light on marketing it to trying to build up the number of manufacturers and helping them navigate that process.
Yes, exactly. And with the manual, we want to be very clear how much investment time is needed so that we can give them a better sense from the very beginning what this might look like. So just, the investment from the beginning, Good Clean Love was like, yes, we'll do anything, right? But none of us really knew how much time or energy or money it might cost. So we want the manual to help businesses understand that from the very beginning to manage those expectations.
And then I'm going to ask one more question, and then I do want to shift over to our other presenters, and then we can come back to everybody. But I was curious about the requirement to do the customer survey, and did that come from Safer Choice itself? Because I don't see that as part of their standard, or did that come from the profiler?
No, that came from EPA, and it is a bit, it was a bit confusing because I think the messages internally from EPA, because it's a new product category, it was just very unknown, right? I mean, it was like, what do we do with this? Is our consumers going to believe that safer means on a personal lubricant, meaning that you won't get an STD? We don't know. So I think the concern, it was certainly valid. It was just a surprise to everyone at the table. So, and it's just one of those things that we have to get through when we're looking at new products. The other question was, no, we did not, I don't think, do a great job at educating the businesses about how consumers are more likely to select Safer Choice. I think in the beginning, when we're recruiting the businesses this next time, we want to have a great presentation that shows this data. And in our first pilot with the interns, it was kind of like, I talked to them, we were like chatting, and I was like, this is an amazing program. We sent them some videos, but we want to have a more dedicated educational and information session for these interested businesses that show them how successful this label is.
Great. Well, I don't want to cut off all the questions, but I do have, and this is apropos in terms of how people actually then design products to meet not just Safer Choice, but other labels, but more importantly, are just designed to be greener. So I am happy to turn it over to our next two presenters, Robert Brown Sr. and his colleague, Laura McAllister. They're both with the local industrial user program at the City of Los Angeles Sanitation and Environment. And Robert Brown is a senior environmental compliance inspector, and he covers laundries, car washes, auto repair facilities, and the like, and is responsible for supervising inspection activities to large districts as in LA San, which is the South and the Harbor. And Laura McAllister, his colleague, is a engineer with LA San. She works to assist businesses to become more sustainable despite the impediment of the myriad of regulations. And she's an engineering associate in the local industrial user program. And she has a background in environmental engineering from UC Riverside. So with that, I would like to turn it over to Robert and Laura. And Laura, if you want to go ahead and share the screen, you got it. Very good. Take it away.
Sorry, I was trying to figure out how to unmute myself. Hi, everyone. I know this is a green chemistry session, but I want to let you guys know that, or get you guys into the mindset that nature was the original chemist. I would also like to mention how green chemistry and biomimicry can become friends or become intertwined, how intertwined they are. There's this company called Hairprint. They were actually able to design a hair dye based off a beetle's shell, which hardens and softens. How they were able to do this, they copied those principles and was able to make a hair dye that was like basically all green chemistry, super sustainable. You can actually eat this hair dye. And it basically brings the melanin back into your hair just by copying a beetle's shell, which I find very, very interesting. So let's, no, I don't want to leave. Okay. So hi, my name is Laura. I'm from the city of LA, and with my coworker, Robert, he's a senior environmental compliance inspector. And today we'll be going over thinking biomimicry specifically for the laundry and textile industry. So what we'll be going over today is what is biomimicry, the 3 levels of biomimicry, our sector champions program, some case studies, and then final tips. So what is biomimicry? Biomimicry is the use of biological principles to influence the design, optimization, and processing of sustainable products and processes, as well as solve environmental challenges. That's a lot. So you might be like, okay, what does that even mean? Let me give you an example. So who here has been on a hike? Hopefully every single one of you has gone on a hike. And have you ever got those like little prickly plants that stick to your socks? Well, I certainly have. Normally, we just throw those socks into our washer, call it a day. But the inventor of Velcro was like, wait a minute, why is that? So he started analyzing the properties of this plant, and he realized that the plant has like a hook-like mechanic, and that's how he invented Velcro. So what biomimicry is you're mimicking biology, you're mimicking nature. So there are 3 levels of biomimicry: mimicking form, mimicking process, and mimicking system. I'm about to go through it. So first, mimicking form. Mimicking form takes inspiration from nature's form. So you're just copying different forms of nature. This can make more products more durable and adaptable to everyday life. So I love giving examples, and let me give you an example of the Japanese bullet train. The Japanese bullet train is the fastest train in the world. However, when it was first made, there was a huge issue about the bullet train. Every time you went through a tunnel, it created this huge sonic boom that like traveled half a mile away from the train tracks. That's going to cause some issues for residents living by it. Luckily, the engineer who designed the train was an avid bird watcher. And he noticed that, I believe it was a kingfisher's, which is a picture of the bird right here, kingfisher. So when the kingfisher actually goes into water, it doesn't create a puddle or ripple effect. So he decided, hey, since it doesn't create a ripple effect in water, maybe that will work with sound. And not only did it work, the train actually used less, like 15% electricity, and actually traveled about 10% faster. The second example we have is mimicking process. So mimicking process is like you're making products that use natural processes. So you can improve product integrity, safety, and sustainability. So let's think about this. There's a company called Threadsmith. They looked at the lotus leaf. So lotus leaves are very interesting. They're always self-cleaning themselves. They're very clean. Something drops on it, just falls off. So Threadsmith decided to use nanotechnology application that mimic this process. Is basically stain-free. By doing this, they were able to make their products more versatile and longer lasting. Also, these products require it to be like washed at like cold temperatures, which make it even more environmentally friendly. And third, we got mimicking system. So mimicking system, you're mimicking a natural system. This can be a cost-effective, it can improve business relationships and streamline the flows of ideas, talents, and capital. Let me talk about this for a second. So what does mimicking system really mean? When you're in nature, or like when an animal dies in nature and it has seeds in its belly, it will grow into a plant. Then after it grows into a plant, an animal will eat it. Maybe the animal will die again. It's a system. It's always going on. This can also be referred to as circular economy. Let me give you another example of a business doing circular economy. One of my favorite fashion brands, Patagonia. So I don't know if you guys know this about Patagonia though, is if you can, once you're done with Patagonia's materials, you can give it back to Patagonia and they'll give you a coupon. Patagonia will then break down that sweater and then you get a new one, or they'll make a new one. So it's a circular economy mindset, which we can, sometimes you can do with chemicals as well. You can keep reusing chemicals. So what are the benefits of biomimicry? Well, it promotes sustainability and environmental awareness. It creates safer and more reliable products. It reduces waste and energy use. It promotes creativity and curiosity. Did you know? So a study was done in the University of Kansas, and they sent like, I think 4 backpackers out. They're like, go away for 4 days in nature. When they came back, their creativity increased by 50%. Yeah. It rebuilds our relationship with nature. It's really like modern day humans, and I know it's gotten worse with COVID. We spend about 90% of our time indoors. That's insane to think about. Like, we're always inside, we're like always on our screens. We don't actually, we've had such a disconnect for nature, and like nature can really improve your mental health. And like I said, promote creativity and curiosity. So going outside in nature is very important. It's very important for us to rebuild our relationship with it. Also, it builds stronger communities. I was researching about it, and the more green spaces you plant in a community, the more safer it is. So how can industries think biomimicry? Well, first, oh, I don't know why it looks like that. Sorry about that, guys. Well, first, let's talk about the dire situation in fashion. I believe this picture was taken in India. You can see just a bunch of like dye polluting the river. Very, very sad. The fashion industry is the #2 most polluting industry after oil. The fashion industry contributes to 20% of all water pollution in the world. Just one pair of jeans takes about 1,800 gallons of water just to make. And the problem with Americans, we keep buying, like, I know you guys probably heard about the shortages that are about to happen. Well, like, it's just because we keep buying stuff. Like Americans, we throw away about 81 pounds of clothes per year. Like, we just don't stop buying it. And like, that leads to 1 garbage truck of clothes being burned or landfilled every second. So I'm going to turn it over to Robert, and he's going to talk about our sector champion program, which we go into industries and we help them be more sustainable.
Thank you, Laura. This sector champion program, it was established to provide support to industries to promote sustainability and productivity through regulatory assistance, biomimicry, the circular economy, and green chemistry. It also promotes employee development on project management, leadership, teamwork, and presentation skills. And here is a shot of the sector champions and the industries that they represent. Sector champion activities, we join trade associations, develop project management and execution, conduct seminars and outreach, promote green businesses, green business certification, organize webinars, and we attend business summit expos. Some of our accomplishments are as follows. Food Manufacturing Group joined the Food Industry Business Roundtable. The Food Manufacturing Group is collaborating with Recycling Market Development Zone and California Market Technology Consulting to assist businesses that use or manufacture recyclable materials. The Car Wash Group hosted a symposium involving car wash operators and the regulatory agencies. The Cannabis Group prepared a 2-day symposium. The Metal Finishing Group presented a 2-year plan to implement pollution prevention goals for Industrial Waste Management Division. The Laundry Industry Group published a newsletter and discussed biomimicry. And that is how I got involved with biomimicry, because Laura McAllister was a member of our sector champion group, and she brought biomimicry to our concern. The microbrewery group is developing a bread to beer program with local bakeries and microbreweries. Now, this by no means is all of what the sector champions have accomplished, but this is just a small snapshot. Thank you. We have several case studies. Our first one is by Procter & Gamble, a detergent inspired by snakes and leeches. Next slide, please. The Procter & Gamble developed this product because snakes and leeches they're basically bloodsuckers, and blood on clothes is a very hard stain to remove. So they looked at the activities of these two animals and developed a detergent which incorporates some of their processes, and now they're working on it. It's, of course, it's proprietary right now, but they hope to put it on the market soon. Next. Here we have another product, which is temperature responsive. And this product mimics the activity of pine cones. Pine cones have an ability to change with the temperature. They become more dense as the temperature is lowered, but as the temperature rises, they expand. And so what industry is trying to do is use nanotechnology to incorporate this process. And the group is Scholler Textile USA, Inc. Thank you. Next slide. This one is one of my favorites. This is a coral reef inspired laundry ball. This product mimics the activity of the coral reef, in that the coral reef absorbs impurities and takes them out of the water. Now, what the laundry ball does is it absorbs microfibers. And as many of you know, microfibers and microplastics and microbeads are a very big problem in terms of our wastewater, because these microfibers get into the ocean, where they're ingested by fish and other aquatic life. And so by using this product, we can remove a lot of the microfibers from our wash. And Cora Ball is actually, this product is actually available. You can buy it and just go to coralball.com, their website, for more information.
Okay, so let's wrap it up. Final tips for biomimicry. Ask, how would nature do that? Like when you're trying to design a product, like really open your mind and explore how things work in the world. Shift our design goals from sustainable to just being well adapted. Go outside. Maybe you guys can hold a meeting outside. Go to the local park. Educate yourself. Maybe today you guys can watch a documentary about nature. Use only the energy that you need. Recycle everything. Reward cooperation, because just like how animals feed off each other, well, we do too. Everyone has their own ideas and inspirations. That's why you need a bank on diversity, which is the next one. Demand local expertise, because if you're only getting resources locally. It's like a local ecosystem, like how biomimicry operates. You know, in the nature, you don't see animals from California, you know, benefiting from animals in New York. Curb access from written, bring biologists into the workforce. It could be any field of work, and just really focus on the positive impact of the environment. So before we go, we want to give everyone a little homework assignment. We want everyone this weekend or this week, go on a hike, go to the beach, go to a botanical garden, and just look at a naturally occurring specimen. You can look at a leaf. Just be like, why does that leaf look like that? You can look at the clouds. Why did the clouds move like that? Or animal, like, why is that squirrel's tail so fluffy? Like, why do squirrels even need tails for? Can that fix a solution that we have for humans? And then ask, you know, just ask why, how, and like why and how does it work like that? So I'm going to give you an example of a cactus. So I believe it was a university in Chicago. Students actually recreated a cactus and was able to make a mechanical cactus that was able to absorb, collect, and actually save water efficiently. So I just want everyone to remember that nature has all the solutions. We just need to look. So is everything clear? And we'll take questions. Thank you guys for your time.
Well, thank you, Robert, and thank you, Laura. Really fascinating, and I hope you guys saw the shout out on the comments, the chat about people love the graphics too. So hopefully those will inspire those who are visually oriented, in addition to those of us who can all hear you. So at this point, I'd like to open it up to for questions to either of any of our panelists, Brittany, Lisa, Laura, or Robert, regarding the topics that we covered. I did have one for Laura and Robert. I'm curious to what extent you know or have you given some thought on how your industry assistance programs can encourage people to think about biomimicry or safer chemistry in general in the industries that you guys work with?
So we have a few programs going on. I believe that green chemistry and biomimicry go hand in hand. We are actually, we have a great inspector, Miguel. He is in charge of our metal finishing sector. He actually is developing a green chemistry checklist for industrial users in the metal finishing sector. I'm also currently developing a thinking biomimicry book where it's directed towards government. So any government, like a police officer, can implement biomimicry. A firefighter can implement biomimicry to make communities more safer or just more sustainable. For industries, the best ways for industries to do biomimicry, because biomimicry is a design process, is really just to keep persuading people to go outside. Businesses can actually add green spaces into their buildings, because if workers actually have greenery, they're actually more efficient. They make more money that way. Biomimicry doesn't have to just be like you're designing something. Biomimicry can be a lifestyle, I believe. Robert, do you have something else to say?
No, that's you pretty much summed it up. We also have the circular economy program.
Oh yes, yeah. We also have a circular economy program right now where we're working with restaurants to reduce all their plastic waste. So we're making them into a mindset where they're in a reuse mindset instead, because like how we always teach kids reduce, reuse, recycle. How often do you actually use reuse? You might use reuse for spoons and like plates and stuff, but you actually don't use reuse that often. It's more like, oh, I'll just recycle it. So we're helping restaurants get into that mindset. So at the end of the day, biomimicry is really a mindset that you need to develop.
I'm not seeing any more questions in the chat. If anybody is on the phone or doesn't have access to the chat, feel free to, you can unmute yourself and ask your question. give it just another minute, but while I wait for folks to pop up, I just want to thank all our speakers again for giving us both big ideas to wrestle with and also a great suggestion to get outside, though it is raining here for the first time in a long time, so maybe tomorrow. And also to many practical lessons learned that I think hopefully we can all take to heart and start thinking creatively about how to solve that. So with that, unless there are any other questions, I want to turn it back over to our hostess, Brittany, to move us on to the next part of the agenda, which I think is a break, but I will leave the details up to Brittany. And thank you all again for participating.
Thank you, John. Thank you, Robert, Laura, Lisa. Yeah, so our next up, we have our lunch break, which is scheduled to run until 12:30. So we get a little bit of extra time. We will be back in this same exact Zoom room. So same link you used to get in here will be for our afternoon sessions. So we will see you back here at 12:30. Thanks. All right, welcome back from lunch, everyone. Next up, we have our 6 PPD session. The session was put together by Ken Zarker, who was leading the work for Washington Department of Ecology. Ken Grimm with PPRC will be facilitating the session in his place. You're up, Ken.
Okay, thank you. I am sharing my screen. So welcome everybody. As Brittany said, I will be filling in for Ken Zarker. If you were not here yesterday or were otherwise unaware, Ken passed away unexpectedly on October the 10th. Ken had a lifetime environmental ethic and was a true believer in pollution prevention. This session was a perfect example of his constant collaboration, facilitation, the sharing of ideas and information and projects, and leading the way on emerging issues. This was something that was near and dear to his heart, and we're happy to continue it in his memory. We have 3 excellent speakers. Dr. Jenn Mcintyre, with the professor of aquatic toxicology at Washington State University, Ann Cooper Doherty with Cal DTSC, and Craig Manahan with the Department of Ecology. They're going to be talking about the overview and research findings, some of the findings and regulatory process going on in California, and then ecology's efforts here in the state of Washington. I will not go on too much with their credentials, but they are all involved in some really interesting projects, both now and in the past. And if you haven't looked at the speaker bios on our PPRC Pollution Prevention Roundtable webpage, I encourage you to do that. We'll, in the interest of making sure that our speakers have all the time they need to get their presentations in, we appear to be doing much better today, but even so, I think I'm going to go ahead and ask to hold questions until the end. You can go ahead and type them in the chat box, and we'll bring them up and go through them after all 3 speakers have gone through their presentation. So with that, I am going to stop share and hand this over to Jenn Mcintyre. Are you there, Jenn?
Yes. Sorry, I had trouble finding that link.
Okay, take it away.
Okay. Hi, everybody. Let me start by sharing my screen over here. I'm going to provide background, the science background for the discussion on policy. Here we go. And I'm giving this presentation on behalf of myself and Ed Kaloje, who is on sabbatical right now. So I first want to acknowledge the research partners and funders who've contributed to and supported this work over the years. So the collaboration between Washington State University, NOAA, and U.S. Fish and Wildlife Service contributed the bulk of the research that I will review today. And then there's been more recent and critical collaboration with the University of Washington through the Washington Stormwater Center, of which WSU is also a part. So funding support for this research has been a patchwork over the years, but the annual support that we have received from EPA Region 10 through the National Estuaries Program has enabled the steady progress that we've been able to make across the years. So for about 20 years now, in the Puget Sound region of the Pacific Northwest, our research group has been using Coho salmon as a sentinel for impacts from stormwater runoff. Now, some of the reasons for this is that they're widely distributed, particularly in lowland streams where there's a lot of potential for overlap with human development. Also, they're more vulnerable to impacts from human development because, unlike some of our Pacific salmon species, coho rear in fresh water for at least 1 year before they head out to the ocean. So it's not just the returning adults and then the developmental period, but also a freshwater rearing period. But the real driver for focusing on coho has been that about 20 years ago, a group of Seattle area researchers noticed that coho salmon returning to spawn in urban streams in the Seattle area were behaving abnormally after it rained. And here's an example of that. This was observed in one of the many area creeks that had received a complete makeover in terms of restoring the creek. And the restorationists wanted to know, if you rebuild it, would they come? And the answer was yes. Adult salmon were again observed using these systems, but otherwise healthy looking fish like this one were found dead within hours of seeing behaviors like I'm showing you here. So researchers got involved at this point, and this at the time was led by NOAA Fisheries and the U.S. Fish and Wildlife Service. And I got to be involved in some of that early work between my graduate degrees. And we began studying the issue and found that the phenomenon is both widespread and recurrent, and that the symptomatic fish are displaying a variety of behaviors that include surface swimming and gaping, disorientation, loss of equilibrium, and that this was leading to high rates of mortality that could include pretty much the entire run in some of the smaller systems. We were struggling to restore salmon. Population modeling by NOAA Fisheries researchers demonstrated that even modest rates of this pre-spawning mortality would be expected to lead to local extirpations. So the mortality through this 7 years of study was not explained by simple things like, oh, the temperature's too high, or dissolved oxygen's too low, or there were pathogens involved in the fish that got sick and died, or even concentrations of commonly measured toxic chemicals. None of those could explain what was being seen. So instead, the weight of evidence pointed to an influx of stormwater runoff. Common pollutants like metals and hydrocarbons, we did see evidence that fish were exposed to those, but they didn't appear sufficient to explain the mortality. So the reason urban stormwater runoff is a problem is because this extreme example especially is not a forest, right? So it can't act like a forest when it rains. And we know that in undeveloped landscapes, most of the rainwater that doesn't evaporate will infiltrate into the ground, and very little will flow off into surface waters. And we know that in our built up landscapes, very little of the runoff is able to infiltrate, and most of it is carried into surface waters, and along with it picks up a whole slew of pollutants. All right, so what is about the stormwater though that's killing coho? Right, after our initial results documenting mortality in 7 Seattle area streams, more of these extensive spawning surveys were conducted to understand how widespread was the phenomenon. So NOAA Fisheries and U.S. Fish and Wildlife Service worked with local municipalities, with tribal nations, and some nonprofit groups to gather information from more than 50 basins. So with this information, they conducted an extensive land use analysis to predict, I'm showing you here a map of that predict where you would see higher versus lower rates of the pre-spawning mortality. So not surprisingly, the higher rates associated with the redder colors here are focused around the more developed basins. But when you look at the different land use analysis results, see that it's not imperviousness or development more generally that's associated with higher rates of mortality, but instead more specifically with roads and with higher rates of traffic on those roads. So 10 years ago now, almost 11, we began to study roadway runoff during rain events. So here we had a convenient spot in Seattle where downspouts from an elevated road actually dumped directly into the parking lot at NOAA Fisheries, the Northwest Fisheries Science Center, where I was collaborating at the time as a postdoc. Here's just a close-up of that first downspout we looked at and a photo of the first runoff that I collected in 2011. So we began exposing aquatic animals directly to this road runoff to start to understand what it might be doing to animals when it entered receiving waters. In each of these PV tubes, we have one adult salmon. The front end is where their heads are, and it's aerated, and this is a good way to confine wild animals when you're doing experiments like this. So we found that by experimentally exposing adult coho salmon to roadway runoff, that we were able to recreate the acute changes in behavior and also the pre-spawning mortality that we were seeing in urban creeks. And there's an example on the right of a fish that's showing advanced symptoms of this phenomenon. So we see that coho are acutely sensitive to urban runoff, and we see mortality sometimes within just a few hours, but certainly within a 24-hour period of exposure. And through various experiments, we've seen that this affects not just the adults, but also sensitive are juvenile coho and recently hatched alevin. The embryos appear to be protected, instead showing sublethal impairments, but it looks like they become vulnerable when they hatch. So of course, urban stormwater is, urban creek waters are not 100% stormwater, at least not most of them. But we found that very little runoff is needed to cause the mortality. So here I'm showing you runoff collected from 3 different storm events, and that they produced, dilutions of that runoff produced similar levels of toxicity, essentially 100% mortality at 25% or greater, and significant mortality even at 5% runoff. And Ed Kolodziej's group at University of Washington, Tacoma has estimated, a quick estimation that urban creek waters can be the equivalent of something like 15% runoff from a busy road, like the one where we collected this water here. So using juveniles, we were able to track the progress of the illness. So a change in behavior that we have observed is surface swimming. So surface orientation and then swimming at the surface. So this figure is showing the amount of time that fish were swimming at the surface during a runoff exposure. So it first detected an increase in surface orientation at about 45 minutes into the exposure. And then those discrete events progressed to continuous surface swimming before eventually losing equilibrium and finally becoming immobile. So although the fish were dying around 5 or 6 hours in this exposure, the effects on behavior were evident as early as 45 minutes. Now, importantly here, we found that juveniles that had transitioned to this continuous surface swimming behavior were not able to recover when we put them in clean water. So they died at the same rate and in the same amount of time as the fish that just stayed in the runoff. In addition to the concentration of runoff that fish are exposed to, the duration is also important. I'm showing you here results from 3 dilutions of runoff from a single storm, so a 25, 11, and 5% runoff, at exposure durations anywhere from as short as 1 hour to a full 24 hours, with the whole experiment being 24 hours. So if they're exposed for less than 24, the rest of the time was in clean water. Now, over the 24-hour experiment, no coho died after 4 hours or less in the lowest concentration of 5% runoff, after just 1 hour in the 11% runoff, but at least some mortality occurred in all of the other exposure combinations. Now, an interesting result here is that the high rates of mortality that we saw in a full 24-hour exposure to runoff was caused by much shorter durations. So look at the results for the 25% runoff exposure. So nearly all of the mortality that was observed in a 24-hour exposure was actually caused by that even just an 8-hour, right? Most of those fish were already dead by 8 hours. And then nearly all of that mortality was actually triggered by even shorter exposure. So 4-hour exposure resulted in nearly the same 24-hour mortality, But at the end of that 4 hours, very few of the fish had died or were even evidently sick, even showing symptoms like we were used to seeing. So instead, these short exposures culminated in sickness and then death after they weren't even in runoff anymore. So this means that stormwater pulses don't necessarily need to be very long to trigger a mortality event. All right, what's happening to these fish as they get sick? We have found that the blood of sick fish shows osmoregulatory imbalance, so low plasma sodium and chloride, for example, and that it's hemoconcentrated. The blood can be twice as thick as in unaffected fish. We still don't know what the target tissue is or the molecular initiating event, but we've been making some progress on this. My PhD student, Stephanie Blair, recently published a paper, I guess it was in January now, where she explored that hemoconcentration in the sick fish. In this experiment, she was focusing on fish that were at that stage of loss of equilibrium. And she injected a high molecular weight dye into their hearts and allowed their circulatory system to move that dye through their bodies.
Get out. If you
She then rinsed out all the blood out of the fish, frozen and sectioned the body. And then she measured the fluorescence. So this high molecular weight dye fluoresces. And the only fluorescence that would still be in these fish is where plasma and large molecules like the dye had leaked from the vascular system into surrounding tissues. So this figure is showing those results. So in these boxes, in this box here, you can see the hemoconcentration of the fish that had been in runoff compared to controls. And then the quantification here on the left of the images I'm showing you on the right. These are just an example, and there were many fish in this study, but we're seeing just a side view of the fish highlighting just two regions, the brain and then the olfactory rosette. And what we're seeing is that a huge amount of leaked tracer in the brain tissues. So tissues in humans and also fish can be leaky to various extents, but the blood vessels in the brain should not be permeable like this. That's what the blood-brain barrier is for. So this apparent loss of vascular integrity, allowing something like a high molecular weight protein to leak into brain tissues, is the focus of our ongoing research. All right, so among other salmon species, we do find that coho are somewhat uniquely sensitive. In co-exposures with adult chum, we don't see the blood changes, we don't see behavior changes, blood changes, or mortality in chum. Among juvenile salmon that we have tested, the next most sensitive we found was steelhead and chinook, with juvenile sockeye and juvenile chum showing no acute mortality. So there may very well be acute sublethal effects that we should be concerned with in other species and also in coho that are exposed to sublethal concentrations. Okay, but let's get back to what is it in the runoff that is lethal to coho? What is it in roadway runoff? This was actually a very difficult question to answer. Urban stormwater runoff is very chemically complex. We know some of the chemicals present in that mixture, and I liken that to the tip of the iceberg, but very far from all of them. So some work done in just the last few years involved Ed Cologie's lab and some of his postdocs, reporting thousands of unique chemicals being present in roadway runoff samples, exploring the identity of some of those chemicals. Very many of them aren't even identified yet, let alone do we know a lot about them toxicologically. And finally, the chemicals that we were familiar with, metals and hydrocarbons, for example, don't appear to be able to cause this mortality. We initially made mixtures of metals and hydrocarbons and thought we could study the acute mortality phenomenon with that kind of a synthetic mixture, but those produced no observed effects, including at higher concentrations than we would find in runoff. So we knew we were missing something. And instead of sorting through this chemical soup and trying to make those individual identifications, we started to study the sources of chemicals to roadway runoff, right? These are coming from particles, from tire wear, from exhaust, from brakes, and the various fluids we release either intentionally, like windshield washer fluid, or unintentionally with leaks from our vehicles. And each of these sources is itself a complex mixture of chemicals. So we looked at the chemical similarity of various vehicle sources to waters that kill Coho, so samples of roadway runoff and urban receiving waters. And this figure is showing the relative abundance of, I've written here, 75 non-target chemicals in each of these source or water samples, going from basically absent at the dark blue to highly abundant in the dark red. And it was only tire particles, that was the only vehicle source that was found to be chemically similar to waters that kill Coho. So this gave us a clue that tires might be the source of the acute toxicity. Of course, to really answer that, we wanted to go back to the fish, because just the fact that a lot of tire chemicals are present in water did not necessarily mean that they were responsible, right? So we compared the effects of stormwater that we previously studied with a leachate that we made from tire particles. Now, if tires were an important source of the toxicity that we were seeing from stormwater, we would expect that tire leachate would cause, one, acute mortality in Coho, that it would not cause acute mortality in chum, and that the pathophysiology, the behaviors and those blood changes that we had studied with stormwater in Coho would also be evident from tire leachate. So we made a mixture of particles from the tread of 9 different tires, and we recirculated water over those particles just at ambient temperatures for 24 hours to allow chemicals to leach out of the particles and into the water. So what was the answer? we know that stormwater is acutely lethal to Coho, I mentioned, does not appear to affect chum, and that when Coho gets sick, they show high hematocrit and a variety of these plasma changes. So through a series of experiments, we show that each of these was also the case for tire leachate, including that extreme difference in sensitivity between Coho and chum. So yes, it did appear that tires were the source of the acute toxicity that we see when Coho are exposed to stormwater runoff. So to isolate the responsible toxicant, we paired toxicology exposures with high-resolution mass spectrometry. And this analytical technique essentially detects, I'll say all, of the organic chemicals present in a sample. It tells you that different chemicals are there, you learn the mass and retention time of those chemicals, but it does not tell you what those chemicals are, okay? That requires more digging. So we made a tire leachate, as I mentioned, by recirculating water over tire particles, and then we fractionated this leachate to reduce its chemical complexity. All right, initially we did this by filtration through sand to remove particle-bound chemicals. We used chelation to remove metals, and then subsequent steps that I'll show you in a second here. So each of these fractions then we exposed Coho salmon to, using them as a screening tool to track the toxicity. And the fraction that killed Coho still contained our unknown toxicant, right? So we took that and put it back through the high resolution mass spec process to try to identify the chemicals that were present in that toxic fraction. And then we would continue fractionation to further reduce chemical complexity. So this approach did work. Our initial leachate contained more than 2,000 chemicals. I don't know if you can see my mouse there. And each fractionation step resulted in one toxic and up to several non-toxic fractions, through which we were able to sequentially reduce that chemical complexity down to a toxic fraction that contained just 4 chemicals. And this final fraction was dominated by a compound with the formula C18, H22N2O2, which was present in the leachate at about 30 micrograms per liter. So what was this chemical? NMR, nuclear magnetic resonance, later confirmed the structure of the chemical was what I'm showing you here, but we still didn't know what it was. Now, it did not appear to be an ingredient in tires. Jenn Mcintyre, the lead author on the science paper that discovered the identity of this chemical, he was the one who made the association between this unknown chemical and the anti-ozonant 6-PPD that has the same number of carbons and nitrogens, but slightly different numbers of hydrogens and oxygens, which makes sense. So the team then purchased industrial grade 6-PPD, and then through ozonation, produced a mixture of transformation products that included this unknown, which we now called 6-PPD quinone. We used toxicology screening after that to validate that this was our toxicant and that 6-PPD was the parent compound. So although 6-PPD produced little to no acute mortality, the ozonated 6-PPD and the purified quinone, whether it was purified from the ozonation of 6-PPD or from the tire leachate, both of those were highly acutely lethal. All right, and finally, to explore the environmental relevance of the toxicant, we examined mortality curves for dilutions of roadway runoff and tire leachates on the basis of their 6-PPD quinone concentrations. That's the top panel I'm showing you here. Now, the median lethal concentration for the various waters was about 0.8 micrograms per liter of 6-PPD quinone. Panel B then is the dose-response relationship for just the purified 6-PPD quinone. And the LC50 is essentially the same, suggesting that the toxicity of the more complex mixtures of tire leachate and stormwater runoff could be explained mostly by the concentration of the quinone that was present. So this allowed us to conclude that 6-PPD quinone was our primary causal toxicant. We also showed that 6-PPD quinone is present above lethal concentrations in all roadway runoff samples that we analyzed. In most stream samples from Seattle that were taken around mortality events, the concentration of quinone was near or above the median lethal concentration. And this quinone was detected in runoff or receiving waters from a variety of West Coast locations. So this encouraged us to conclude that we would expect to find 6-PPD quinone anywhere with a lot of tire rubber particles present. So what do we do about this? One thing we can do is build green stormwater infrastructure. These are technologies that encourage runoff to spread out, soak into soils instead of running directly into surface waters. So things like permeable pavements and bioretentions, and we study a variety of these at the Washington Stormwater Center. So despite not knowing what the responsible chemicals were, we did previously show that bioretention filtration can prevent the acute lethal effects of roadway runoff on Coho salmon. So these experiments that I'm showing you videos of, fish were exposed for 24 hours to either clean water, runoff, or runoff that had been filtered through bioretention. And I'm showing you fish behaviors at just 4 hours into the exposure. And in runoff, the fish were already sick. You can see them doing that loss of equilibrium behavior here. And they died soon after this. But the same water that passed through the bioretention system on the right caused no acute effects for these fish. And we have also shown this, that this is true for juveniles and for alevin. And that it can prevent sublethal effects that we see in developing fish as well. Okay, another solution really briefly here is source control, which is something that we've started to explore. We've been talking with the US Tire Manufacturers Association and with groups like Salmon Safe about incentives and marketing opportunities for tires that are salmon safe. The last thing I'm putting up here is just a list of ongoing research that we're involved with for 6-PPD quinone, things ranging from environmental toxicology, including, what other species are vulnerable to this chemical, what is its toxic mode of action, what are sublethal effects to be concerned about, things in the environmental toxicology and chemistry category, including safer alternatives to 6-PPD, so that we don't get 6-PPD quinone produced in the environment so much. And things like what are the environmental conditions that affect bioavailability and toxicity. And then environmental chemistry, questions related to the rate of formation and release of 6-PPD quinone from tires, transport in air and water, and the temporal dynamics in receiving waters. I'm taking up some of Craig's time here that he offered up. So in conclusion, I want you to take away from this that tires are a really source of really complex mixtures of chemicals that get into the environment, and we're starting to understand just how prevalent they really are in different environmental compartments, and that we're going to need both approaches like green infrastructure and source control to address the problems that we're seeing from these chemical mixtures, including 6-PPD quinone. And finally, the idea that 6-PPD and chemicals like this that are designed to be highly reactive, 6-PPD, I think somebody else is going to go over this, 6-PPD is designed to react with ozone. Maybe I didn't say that. And because it's designed to be reactive, it's going to make transformation products, and we should be trying to pay attention to what those reaction products are and whether they're safe for our environment. All right, I'm going to pass this on now to our next speaker. Thank you.
Okay, that will be Ann, and that was really fascinating, Jennifer. Thank you, and Craig, thank you also for giving up some of your time. I don't know if we'll regret it later or not, but we certainly don't now. So take it away, Ann.
Thanks so much, and thanks to Jen for doing a great job setting up my talk. So I am from California's Department of Toxic Substances Control's Safe for Consumer Products program. And I want to talk through our work on 6-PPD and 6-PPD quinone, as well as give you a bit of an overview about our program. So to start with, we have officially proposed motor vehicle tires containing 6-PPD as a priority product. Exactly what that means, I will get into in a little bit. But in terms of the timeline, we took that science publication from December and kind of ran with it. And we released our proposal in June, record speed for our program, really. And that's based on the really great story and work that was done by the researchers in Washington. Part of the reason why we wanted to move as fast as we have is obviously it's a really serious problem. And we wanted to ensure that our process could be used when evaluating alternatives to hopefully prevent regrettable substitutes. And USTMA, the United States Tire Manufacturers Association that Jen just referenced, is supportive of our potential regulations. So we also had a great workshop on chemicals in tires, including 6-PPD and 6-PPD quinone, but also other associated chemicals in July. Stephanie from Jen's lab, as well as Ed and some other researchers all presented. And it was really great. And the recordings and slides for that workshop are available on our website. So the Safer Consumer Products framework is essentially 4 steps. Simona Ballan's our colleague who presented on PFASs this morning. So you may have gotten a glimpse of this already. But I want to walk through each of these for you so that you can kind of understand what it means that we have proposed 6-PPD in tires as a priority product. So the first in our 4 steps is our candidate chemical list. So this is essentially 23 authoritative lists that we kind of mash together into one larger list that we call our candidate chemical list. And these are authoritative lists that are focused either on hazard traits or exposure to these chemicals. And so this candidate chemical list, as we call it, can include individual chemicals like 6-PPD or really large classes like PFASs. So as a result, it can number into the thousands. Exact numbers is a little tough to get, but it is fairly expansive. And that forms the menu of chemicals that we can pick from when we're trying to prioritize what to regulate through our program. So that's the chemicals. And then the next step, and one thing that I think makes our program a little different, is that we then look at it through the lens of products. So step 2 is our priority product process or step. And that's where we evaluate product chemical combinations that may cause harm. So the menu for this step comes from our priority product work plan. So our most recent edition of that was 2021 to 2023, in which we added the product category motor vehicle tires. So that expanded our focus to include that category and the chemicals associated with them. So in this step, what we're trying to do is evaluate and prioritize chemicals in the context of products. And we do that by considering the potential. So the word potential is really important here. That means the bar for us is somewhat low, particularly compared to other regulatory constructs. So we're looking for the potential for exposure to the chemical from the product and the potential for significant or widespread harm from that exposure. So we prioritize product chemical combinations and eventually list them through rulemaking, at which point they become an official priority product with our program. And then that moves us to the third step, which is the alternatives analysis step. And this is when manufacturers evaluate safer alternatives. So in most cases, each manufacturer will conduct an AA, as we call it, and they conduct a life cycle evaluation of the chemical and the product, and they compare possible alternatives. And one thing that's also unique about our program is that they use their own knowledge and values to decide on alternatives. It's not something that our program does. And they put that all in a report that we call an AA and submit it to us. And those are, of course, all publicly available as well. So once those AAs are submitted, we reach our fourth and final step, and that's our regulatory response step. And this represents the wide range of possible actions that DTSC can take to protect public health or the environment. Sorry, I think I moved that. So we propose that on a per responsible entity basis. All of those will be available for public comment. So these regulatory responses can kind of range in terms of what they are. So we can do no response if we think everything looks good and there's really not much that we can add in terms of protection of public health or the environment. We can choose to do nothing. We can request additional information to DTSC or consumers, as well as additional safety measures. We can put forward sales restrictions or prohibitions, as well as end-of-life product stewardship requirements and research funding. So for things like green chemistry and alternatives. So the scope of the responses that we can pursue are pretty wide-ranging, and they will really vary based on the product chemical combination that we're talking about, as well as each manufacturer and what they propose to do in their AA. So that's our four-step process. And to bring you back, hopefully makes a little bit more sense now that we are in step 2 here. So we have proposed motor vehicle tires containing 6-ppd as a priority product. When we made that proposal in June, we released a technical document which summarized a lot of the great work that Jen and Ed and those others up in Washington have done, as well as some other research that we've conducted. We of course think it's pretty interesting, so feel free to go check that out if you'd like. So next, I wanted to give a little bit more of an overview about 6-ppd in terms of what we've learned about the chemical itself. I'll also go into the basis for our listing and our proposal, the scientific basis, and then talk about kind of next steps for our program. So 6-ppd, as Jen said, is an anti-degradant designed primarily to react with ozone and to a lesser extent oxygen. It's in there to prevent the cracking of rubber. So if you look in the image in the top right, the one on the left contains an anti-degradant and the one on the right does not. And you could see that the one on the right has a lot of cracks in it and is obviously not what you want the rubber on your tire to look like. So the anti-degradant certainly does play an important role in the structural integrity of a tire. As far as we know, it's been used since the 1950s or the 1960s, somewhere in there. And the concentration is generally around 1 to 2% by weight. And as far as we know, it's used in presumably all tires. So one reason for that is some of the characteristics that 6-ppd has, which I think Craig may speak to a little bit as well following me. But we know that it migrates to the tire surface by design, where it reacts and creates a protective film of reaction products, including, of course, that we now know 6-ppd quinone. And the migration speed is a function of the physical chemical properties of the anti-degradant. And this is a bit of a Goldilocks scenario. If it moves too fast, then you lose all the 6-ppd or the anti-degradant too fast. And so it doesn't, there's not enough left over the entire lifespan of the tire. On the contrary, if it moves too slow, then it's not available at the surface as much as is needed to really protect the rubber. So it's kind of this, middle ground that they're trying to reach when finding an anti-degradant that will work in tires. And it also seems that apparently it's only partially dissolved in the rubber initially, and there's a remainder that serves as a reservoir that slowly dissolves into the rubber over the lifespan of the tire. So those are just important considerations when looking at least chemical drop-in alternatives to 6-ppd. So then I wanted to give an overview of at least California's case for moving forward and making this proposal. As I said, we look at the potential for exposure and the potential for adverse impacts. So in terms of the potential exposure, as I said, we know that it's used in presumably all tires, and that number is over 171 million in California in 2020 alone. There are really high rates of release of tire wear particles to the aquatic environment, which can further serve to transport 6-ppd and 6-ppd quinone off the roads and into the ecosystem. There are end-of-life applications of tires, tire recycling practices that may result in additional exposure to 6-PPD and 6-PPD quinone, but that's definitely an area of ongoing research. We don't fully understand that yet. And there has been detection of 6-PPD quinone in California runoff and waterways, as Jen alluded to. So then moving into the potential for significant adverse impacts, we know that 6-PPD itself is toxic at multiple trophic levels, and it can impair wildlife survival and is toxic to algae. 6-PPD quinone, as we've just seen, is acutely toxic to coho at a variety of life stages. And there are environmental detections of 6-PPD quinone in California are above the LC50, indicating that not only is there exposure, but that when that exposure does occur, it's enough to cause significant impacts. So a little more on coho, particularly in California, they have been declining precipitously since the 1960s. This is a figure that's from our technical document that shows just how fast the populations have declined. We have 2 California populations of coho that are left. One is threatened and one is endangered, and our regulations allow us to specifically prioritize impacts to endangered species. So that's certainly the case here. And we also know that coho already face a number of additional challenges: climate change, habitat destruction and loss, exposure to other contaminants, drought, the list kind of goes on and on, but can exacerbate the effects from exposure to 6-PPD quinone. There's also concern that 6-PPD quinone may be toxic to other aquatic organisms, and Jen just gave a preview of that. So especially those that are closely related to the coho, such as the Chinook, golden trout, and steelhead or rainbow trout. As you can see from this phylogeny from our document, how closely related these species are. So that's obviously a field of ongoing research to really better understand both the acute and sublethal impacts to other aquatic organisms from 6-PPD quinone. And finally, there's potential adverse impacts to human populations. So we know that the loss of coho has significantly impacted California's Native American tribes, and the loss of core traditional food sources can be tied to loss of culture, increased physical and mental health issues, and poverty. And California's Native American tribes and the state of California have invested millions of dollars in an effort to retain, restore, and replenish coho populations. And that's obviously in jeopardy with the presence of 6-PPD quinone in these waterways. So that's kind of the basis of our proposal. And in terms of next steps and where we are right now working on rulemaking documents so that we hope to be able to initiate rulemaking in early 2022 with the hope that the regulations will go into effect the second half of 2022 or early 2023. And that would make the preliminary alternatives analysis, which is the first of the 2-part AA process, due sometime in the first half of 2023. And finally, in addition to that, we are also trying to do whatever we can do to help spur innovation on the alternatives front. Part of that includes increasing awareness of the issue and the need for alternatives. I think in our world, we just assume that everyone knows about this really obviously important issue, but we found that that's not always the case. So trying to spread awareness, educate ourselves about what alternatives may exist. We have something in our regulations that allows that whatever alternatives we post on our website must be considered by the responsible entities in the alternatives analysis process. So we're certainly keen to learn about alternatives that might be something that we should highlight on our website. And of course, continuing to coordinate with others across the West Coast and beyond to continue to understand this issue and see what we can do to help mitigate the impacts. And with that, I will say thank you and turn it over to Greg. Thanks.
Thanks, and let me bring up the presentation. Let me know if it isn't working correctly or if you can't hear me. And that's the wrong screen. Share. Okay, I think that'll work. That's right on my screen. Okay. So yeah, I'm Craig Manahan. I'm from Washington Department of Ecology, and I want to acknowledge that this is work that Ken Zarker started many years ago. He's been working with Jenn and Ed and the automotive industry on brakes and fluids even before this 6-PPD compound was discovered. So we're hoping to continue the work that he started earlier. And as you can imagine, there's quite a bit of work going on in Washington, including at Ecology. This is just a quick overview of some of it. And I won't go into details there. So this year, we got a appropriation from the legislature, a budget proviso, to our program to assess potential hazards of 6-PPD and other chemicals, alternative chemicals used in tires. And we have a technical memo due in December. And so what we're doing for that is we're performing green screen hazard assessments on 6-PPD and 9 potential alternatives. And then we're going to publish a technical memo summarizing the findings of these results. And then we also have some agreements in place that haven't quite started yet to conduct toxicity testing of 6-PPD and 6-PPD alternatives on Coho salmon and rainbow trout, because that is a data gap that is still present. Is we know 6-PPD quinone is acutely toxic to Coho salmon, but we don't know how toxic these potential alternatives are towards Coho salmon or in general, a lot of other aquatic species. And for those of you who don't know, green screen is a standardized method used to assess hazards of chemicals. It's broken up into different endpoints, and it gives a different score for each endpoint, as well as an overall hazard score for the chemicals. And we picked our chemicals basically by looking through literature. We talked with some manufacturers. We talked with the US Tire Manufacturers Association, and DTSC in their priority products report listed some potential alternatives. And so we picked out some of those to evaluate in our hazard assessment. And this includes several other PPDs, which would presumably work similarly to 6-PPD. And we know they have been used in the past or are currently used in tires or other types of rubbers, as well as some other types of chemicals. Because as I said, we don't really know that much about these other PPDs, if they will be similarly toxic to Coho or not. So we still haven't received those green screen results, but we should get them pretty soon, and we'll review them and write up this technical memo, which basically is just going to summarize the results of the green screens and get them to the legislature by early December. But we likely won't see the results of toxicity testing on 6-PPD and alternatives until at least mid-2022. And so some work that's being done in other programs at Ecology is that we also got some money from the legislature to do some other work, which includes identifying priority areas affected by 6-PPD or other chemicals, identifying best management practices, and developing a standard method for laboratory measurement of 6-PPD quinone in water. And so there's another technical report due to the legislature in 2022, in November 2022, which will sort of overview all those areas and hopefully sort of prioritize what we're going to be doing, the work that we'll be doing at Ecology in the future on 6-PPD. We also have some programs from Ecology that are partnering with, or as part of that, we have water quality and our environmental assessment program partnering with Washington State Department of Transportation and researchers at UW-Tacoma and WSU. We've also got some stakeholder discussions going on about treatment, which, as Jenn mentioned, will include some green stormwater infrastructure. And then we have MEL, our environmental lab, which is developing our testing methods. So we have work going on all three of those areas currently. And so as Ann Cooper and Jen outlined, 6-PPD is a little bit different than other chemicals we've been concerned with in the past. We need this green stormwater infrastructure to effectively treat it, we think. And Jen showed that filtration through sand and compost protected adult coho salmon. So that's one area that ecology is really focusing on right now, is how we're going to use these enhanced stormwater treatment in the future and where to prioritize those efforts, because we can't, unfortunately, it's not feasible to treat all roads in all of Washington State right away for this. And yeah, so that's about it. I just wanted to be quick and get through what we're doing at ecology, but I'm happy to take any specific questions. Thanks.
So thank you very much to Jen, Ann Cooper, and Craig. I personally found it all very fascinating, and final thanks to Ken Zarka for putting this together, because I think this is really something we've been trying to find answers to for a while now. So in that regard, it looks like we had a number of questions come in, most of which were answered along the way. So I'd like to do two things. First of all, I'll talk to Elena when this is over and see if we can get a printout of those, and I will put them on the website along with a link to the presentations so that folks can look at those later. And then I would like to open up the floor. We have about 10 minutes left. If anybody has a question, please feel free to ask it. But not all at once.
I don't know if you wanted questions in the chat or.
I'm happy to just take them at this point. I don't think we have to limit to the chat because the presentations are done. But the only one I see that hasn't been answered is the one that just came up from Paul, which is have tire manufacturers been open to looking for and adopting alternatives to 6-PPD?
I can start on that. Craig may be able to finish up, or Jen, but I will say, at least with our work, they have been supportive of what we're doing and actually wrote our director asking that we work on this. So they do seem interested in really evaluating and hopefully coming up with a safer alternative. And they have been working with us on the process.
And from the research perspective, USTMA did recently re-engage the Washington Stormwater Center as the umbrella of WSU and UW to talk further about the alternatives. It's not something they were talking very much about initially after our research came out, but now we do hear them talking about, the need to find an alternative, and have been sharing with us a little bit about their process, including being involved with DTSC to try to identify what that alternative will be.
And I will say, sorry, just to add on to that, is one thing that we have learned is that tire formulation is really, really complicated and harder than, a lot of the other work that SEP has done so far may be in, formulated products that are a little bit easier to kind of, adjust and see what works. And tires are certainly a complicated product. So it's a complicated process.
Okay, I have a few more here. Oh, I'm sorry, Craig, go ahead.
I'll just add that we've already gotten comments from USTMA on the alternatives that we're assessing as part of our report. And they had some considerations about things, and they're the ones who ultimately, they have to tell us if the alternative, even if I identify it as not killing salmon, they have to be the ones who tell us if it will work or not, basically, with their tire manufacturing process.
So another one here is, have manufacturers of other types of rubber products been at all involved, or will they be involved in the alternatives analysis? And if so, what types of products?
For us, at least right now, we're focused on tires. Those seem to be the most dominant source. There was actually a webinar from Eurofins the other week that said that they found 6-PPD quinone in the rubber on windshield wipers. So there definitely may be other sources, and almost certainly are. There's also been detections of other PPDs, like in road dust in China. So there definitely may be other PPDs out there as well. But for right now, we're focused on 6-PPD and tires, as those seem to be the biggest source.
And I will add to that during our recent meeting with USTMA, they are also attempting to engage the, trying to think of what they called it, some consortium for REACH, right? So for regulations in Europe, there are consortia for certain types of chemicals, and there is a PPD consortium. And so USTMA has been reaching out to them to hopefully get them involved more directly in assessing alternatives.
Thank you. Has the chemical industry that makes 6-PPD been involved at all?
As Jen said, yeah, we've had some discussions with the REACH consortia or some other manufacturers in the US. So they're aware of the issue, at least, and have talked with us.
Yeah, us as well.
Well, that's kind of an interesting question here. It says, can the fish uptake a sublethal level, then pose consumption risk exposures?
Yeah, good question. And as we all know, that usually means we don't know the answer. And that's the case here too. We just know very, very little so far about the kinetics. And so we don't know yet whether it does accumulate in fish's tissues and whether it may pose a bioaccumulation or biomagnification hazard.
There's a question here. They ask, could it be considered a point source pollution or pollutant?
Jenn, me. I've been asked this one a few times. I think it kind of depends on how you define. I mean, I think the tire wear particles would be more of a non-point source, but a pipe obviously coming into Jen's lab, that's more of a point source. But stormwater that's diffusely coming off of the side of a road might be non-point. I don't know. Potentially up for discussion.
Yeah, I suspect that they were asking in terms of looking for potential regulatory solutions as well. And it looks like, are the tire manufacturing companies jumping into the green chemistry at all?
I guess it depends on what you, how you define jumping into green chemistry. There's certainly, at this point, seem to be embracing our process and realizing, I think, that the benefits of a really thoughtful consideration of alternatives across the entire life cycle. So that's what I can say so far.
I thought the word jumping was a disqualifier, but
rolling, maybe they're rolling into it.
There is some research going on in things like natural rubber tires and non-pneumatic tires and that sort of thing. And that's been going on for a while. And we aren't really quite there yet, but there is some sort of alternative tire type of research that's going on as well.
Yeah, the only thing that I will say on that is that what I found, at least, is that in some of that research on looking at more, sustainable sources of rubber, they're often not considering the alternatives. I think because, the additives like 6-PPD that go along with that process. So if it's a green tire or something that has, I think, was it dandelions or something as the source of the rubber, that doesn't necessarily mean that it doesn't use 6-PPD or zinc or any of these other chemicals that may be of concern from tires.
Interesting. Okay. And as a side note for myself, because I don't see any other questions at this point, is there anything? I know it's probably much more expensive to extract and work with, but is there anything going on in the world of Waiuli and rubber replacement? The Waiuli plant?
I'm not familiar with that. You're saying it's a plant that produces a type of rubber?
Well, it can. I know it was something that they did quite a bit of work with in World War II when we didn't have access to all the sources of rubber. And I think the Waiuli is a cactus. I have seen some things that were made with Waiuli, 60, 70, 80 years ago now that it's still held up pretty well, but I suspect it's probably something that is significantly more expensive to manufacture.
I don't know.
Yeah, I don't know either.
Okay, well, I think we're about a minute away from our session being done anyway. So Jen and Cooper and Craig, thank you very much. I found this really fascinating. I'm very happy that I was able to attend. So if other questions happen to come along later, can I send them to you for responses?
Of course.
Okay, well, thank you very much for your time and your expertise. And we will pass it along now to the next speaker, the next facilitator, which escapes me at the moment. So
thanks.
Thank you.
We have a pathway to decarbonization with Alex Bertolucci next. Alex, take it away.
All right, I had to get all my controls and everything figured out there. Thanks for that great session. That was very interesting to hear about. Loving all of these great speakers and everything. Learning so much. So this next presentation is going to be on the pathways to decarbonization. And you know, in P2, we often talk about toxic chemicals, and we don't hear a lot necessarily about energy efficiency, but it's also pollution prevention work. And so it's kind of interesting to hear the speakers today. We've got three amazing speakers who are going to talk about the Department of Energy's efforts to implement President Biden's Justice 40 initiative. We'll look at how energy storage for renewable electricity can advance equitable outcomes, and then look at problematic refrigerants and how to replace them with more climate-friendly ones. So let me introduce the speakers here. We have Yasmin Yacobi, who is an energy justice and DEI consultant at the U.S. Department of Energy's Office of Economic Impact and Diversity. Her work focuses on the equitability and accessibility of energy systems, programs, and policies. She's working to ensure that everyone has access to clean, affordable, and dependable energy. She also loves hiking and is a freelance light designer for various theaters. So if you have some time to chat with her about that, that's a fun one. All right, next we have Dr. Bethel Kierkney, and so sorry if I butchered your name, but when you speak, you can correct me. And she is an energy, equity, and renewable researcher at the Distributed Systems Group at the Pacific Northwest National Laboratory, where her research focuses on understanding the social equity implications of renewable energy technologies. She's currently exploring the equity justice implications of energy storage for the DOE-OE's energy storage program. And if you don't know what those letters mean, she'll tell you. And then Morgan Smith, the Program and Communications Director for the NASRC. Again, she'll tell you what all those letters mean. She has a background in sustainability communications with a particular interest in aligning sustainable behaviors with goals of industries and businesses. So there's who we've got. First up, we're going to have Yasmin. So you want to go ahead and share your screen? I think I saw you on here.
Everybody see my screen and hopefully see the actual presentation and not my notes.
Amazing. We can, and you sound
for the introduction. Amazing. Thank you so much for the introduction, Alex. I'm so thrilled to be here with everybody. Thanks for having me. We're just going to jump right into what we're talking about today. So we'll start with a little bit of level setting definitions. We'll have a moment to talk about the context and historical background. And then we'll talk about what energy and environmental justice currently looks like and the Justice 40 initiative. So to start off, we're going to talk about the difference between equality and equity. And this graphic does a really good job of kind of summarizing what these concepts are. So equality is often used to mean giving people the same resources regardless of their situation. That's the picture here on the left. Equity, meanwhile, is about ensuring everybody has what they need. So that means expending more efforts to some communities than others to ensure that they too end up with fair opportunities for a healthy life. Personally, I love this graphic. It's particularly helpful because the fence is sloped and so is the ground. And so this shows that we don't always start with equal footing. The fence can symbolize institutional discrimination, and the floor can symbolize situational differences. And it's important to keep that in mind when we're thinking about equity and equality. So diving right into some definitions, what is environmental justice? Environmental justice is the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. It's important to note that fair treatment means that no population bears a disproportionate share of negative environmental consequences that can result from industrial, municipal, commercial operations, or from the execution of federal, state, and local laws. And meaningful involvement requires effective access to decision makers for all, and the ability for communities to make informed decisions and take positive action to produce environmental justice for themselves. It's important to note here that the legacy of pollution runs long and deep in communities of color. Black households are more likely than other communities to live in the shadows of fossil fuel generation, and communities of color live with the toxic legacy of air pollution that is a direct result of the system and structures of our energy system. We'll talk about all of that a little bit more in a moment. Before we get into that, one more definition. What is energy justice? So energy justice recognizes that just like environmental justice, the costs of the energy system have not been borne equitably. And we strive for everyone to have access to clean, affordable, and reliable energy. And for frontline communities to have a say in their energy futures. And that's what this definition is saying, the social and economic participation in the energy system, while also remediating social, economic, and health burdens on those disproportionately harmed by the energy system. Energy burden and energy insecurity are two of the common metrics that we use to talk about energy justice. So energy burden is the percent of a household's income that goes towards paying energy costs, and energy insecurity is lacking reliable access to uninterrupted energy sources at an affordable price. And energy insecurity isn't necessarily not being able to afford your energy that month, but it's also needing to make difficult decisions like paying for energy versus medicine this month. Before we keep going, I want to contextualize all of this. I want to contextualize that sloped ground and the raised fence that we saw in that graphic. And I want to contextualize why communities of color tend to be disproportionately impacted by the energy system and by climate change. It's really crucial to recognize that none of this is coincidental. Those legacies are tied to race-based slavery, to Jim Crow laws, to redlining, and to a myriad other government-sanctioned policies and systems. I want to discuss redlining briefly. The redlining maps originated in the aftermath of the Great Depression, when the federal government set out to evaluate the riskiness of mortgages in major metropolitan areas. The maps color-coded neighborhoods by creditworthiness. The problem was that it wasn't actually by creditworthiness, it was really by race. So areas with African Americans and immigrants were almost always considered the highest risk, and they were marked in red on the maps, thus the name redlining. And all white neighborhoods were viewed as safe property value, and banks gave them loans. So redlining made it really difficult, if not actually impossible, to buy or refinance. A lack of investment meant that houses in those neighborhoods fell into despair. That led to health hazards like mold and lead paint. It also meant that industrial sites were more likely to be located near redlined communities, which meant more exposure to pollution. As areas declined, retailers left, including grocery stores, which meant less access to healthy food. These neighborhoods also had less access to parks and green spaces, which means fewer places to exercise. So all of those factors combined to create an environment conducive to poor health outcomes. On top of all of that, homeownership is actually one of the most successful ways to entrench people in the middle class. It builds up wealth that can be passed down through generations, called generational wealth. And so the history of redlining is therefore a history of providing favorable access to financing for white residents in all white neighborhoods, preventing minority populations from building credit and trapping them in a rent cycle. Redlining is a very tangible thing. It began in 1934 and continued until 1968 when it was banned with the Fair Housing Act. And we can see its implications across the United States today very clearly. So why does this matter in the energy sphere? Why did we just go through this history lesson? Well, the data shows that communities that were redlined and deemed declining or undesirable still to this day have the largest populations of communities of color. They have the highest poverty rates. They have the highest rates of childhood asthma and asthma in general. Those same communities have older building stock. They have higher exposure to lead. They have less efficient homes. Those same communities experience higher energy burdens and are more likely to experience energy insecurity and energy poverty. When we talk about energy justice and environmental justice, we are talking about recognizing and addressing these legacies of racism and oppression throughout the United States. Just as these policies were created intentionally, our efforts to undo them must also be intentional. And just to solidify all of this with some charts and some data, Black and brown communities are more exposed to every type of pollution. Here's kind of that look at disproportionate exposure. The left graph shows that Black communities are more exposed than average to every source of fine particulate matter, particularly those from construction and power plants, while white communities face far less exposure than most sources. This is a result of those energy companies placing their factories and industrial projects in communities of color. Another chart here, right? Current asthma rates by race and ethnicity. Black and American Indian and Alaskan Natives have the highest current rates of asthma compared to other races. In 2018, Black folks were actually 42% more likely than white people to still have asthma. That asthma comes from particulate matter and exposure to pollution. This exposure, again, like we were saying, is not fair. What we're seeing is that communities of color tend to be exposed to much more pollution than they produce, over 50% more, while white communities are exposed to less particulate matter and exposed to 17% less. So particulate matter includes dust, soot, and liquids suspended in the air. And these lead to really bad health issues, like we were seeing with asthma, with lung cancer, and with COVID. And lastly, fine particulate matter, we know, is the largest environmental health risk in the United States and globally. It's critical to mention here that electricity generation is a large contributor to fine particulate matter in the US. Specifically, the EPA in 2014 estimated that coal-fired electricity generated 39% of the electricity in the US and contributed to 81% of particulate matter in total electricity emissions. Studies have found that exposure is higher for low-income communities than for higher-income communities, but more important than that, the disparities are larger by race and ethnicity than by income. So for example, like we see here, Black Americans suffer higher premature mortality than other races and ethnicities. So the effect is persistent even across income brackets. These communities are known as sacrifice zones. Those communities that were sacrificed for the betterment of the rest of the country. That's where we place all of our factories. And while the United States has been reckoning with legacies left by systemic racism, these communities continue to be first and worst. So all of that is just a little bit of level setting for why we do this work, why it's so critical to center equity and justice in the work that we do, and why it's critical to really uplift those communities in the work that we do. So how are we addressing this? How are we starting to think about environmental and energy justice at the federal level? The Justice 40 Initiative is one of those ways. So the Justice 40 Initiative is born out of Executive Order 14008. Section 223 states that 40% of the overall benefits of certain federal investments must flow to disadvantaged communities. And that includes clean energy and energy efficiency, clean transit, affordable and sustainable housing, training and workforce development, the remediation and reduction of legacy pollutions, and the development of clean water infrastructure. So that poses a lot of questions. 40% of the overall benefits. How do we measure and track the benefits of Justice 40? Certain federal investments, how do we define Justice 40 investments? And disadvantaged communities, how do we define disadvantaged communities? And it's specific to note that disadvantaged communities can be tied by geography, by a certain location, but they can also be tied by common characteristics and be geographically dispersed, like migrant communities and migrant workers would constitute, could constitute a disadvantaged community. So those are the questions that we're currently thinking about at DOE, and that's how we're starting to grapple with the Justice 40 initiative. With that, we have our policy priorities, 8 policy priorities, starting with decreasing energy burden, the percent of your household income that goes towards your energy bill every year. We also want to decrease exposure to pollutants and environmental burdens. That's been this whole conversation. We want to increase parity in clean energy technology access and adoption, like solar and storage in disadvantaged communities. We want to increase access to low-cost capital in disadvantaged communities. That's going to be the floodgate to increasing parity in solar parity and storage parity in those communities. We want to increase minority business enterprises and clean energy enterprise creation in disadvantaged communities. We want to increase the clean energy job pipeline and job trainings for individuals from disadvantaged communities. And clean energy jobs have a myriad of benefits that come associated with them, including stability and resilience. Speaking of resilience, we want to increase energy resiliency in disadvantaged communities. And it's important to note here that resiliency is not just the ability to bounce back from a natural disaster, although that's critical, but we're not just talking about community resilience, but we're talking about individual resilience as well. Knowing that you'll be able to afford food and energy this month allows for you and for an individual to be able to bounce back as well. And lastly, increasing energy democracy. We want to make sure that communities have a say in their energy future and can help shape it. With those policy priorities, we have our key outcomes. Wealth creation. We want to create pipelines for diverse entrepreneurs through federal investments. And we want to ensure that private sector commitments and philanthropic private sector accelerator capital feed into that. We also want workforce development, creating new opportunities through partnership among the federal government, community colleges, minority serving institutions, et cetera. We want to reduce burden, and that's not just energy burden, but we want to reduce transportation and housing burden through deep investments and couple that with infrastructure investments. And lastly, we want long-term investment. We want to make sure that we create innovation hubs to support community economic growth and leveraging federal assistance from labs and infrastructure and private sectors to ensure that we get that long-term investment. So really, the Justice 40 initiative provides a pathway for equitable, deep decarbonization that transforms and builds wealth in underserved and overburdened communities. We see this as an incredible moment in time where we have a chance to redesign our energy system, and we have a chance to do so equitably and to really center those communities and make sure that they are a part of the conversation. So with all of that, we currently have a couple different efforts underway. We are doing a lot of stakeholder engagement with those frontline communities and with youth to make sure that their voices are heard and are part of this process. We have a bunch of different working groups that we're working with specifically to try to parse out what are metrics, what are benefits, what are disadvantaged communities. And we have a beta dashboard that was published in May. So this is a tool to measure and track DOE progress towards Justice 40. The tool is already up, it's a beta, so we're still working to tweak and refine it. And it has different layers that allows us to see among all of DOE's contracts, cooperative agreements, and grants, where money is flowing and whether it's flowing to disadvantaged communities currently. So I just spoke for a while, so I'll stop there. I'll see if anybody has any questions, and thank you so much for listening.
If there are any questions, I don't see any in the chat, but maybe something comes up for you. Did I hear somebody?
Yeah, I had a question. What is planned to be done in providing access to capital to disadvantaged communities? What is planned to be done to combat the common occurrence of capital flight in those situations where loans are made to municipalities or other public groups? Those loans are used to buy services from private providers or to set up energy companies by private providers, and then that profit is taken out, and then they're left to foot the bill.
Yeah, so that's a great question, and specifically within the context of Justice 40, Justice 40 is not looking at where we invest. It's actually looking specifically at the benefit. And so in this context, that's part of what we're trying to figure out right now, is how we make sure that these investments that are going to places, that we track the actual benefits that are coming out. We make sure that that funding actually makes it to communities. And so instead of looking at dollars spent necessarily, we might look at reduction in pollution or in reduction in energy burden. And so I know that that doesn't fully answer your question. It's a tricky one because there's a lot of, specifically around financing, there's a lot of predatory lending that happens and really problematic things that, like you were saying, can lead to further injustice. And so in the Justice 40 context, we're really trying to separate the investment from the benefit. But I know that's not a satisfying answer.
Excellent. Thank you. And thank you for that presentation. It did set a really great foundation and show some of the awesome work that's going to be done. Dr. Bethel, you are up next.
Thank you. Let me try and share my screen. Do you see the full presentation? Okay.
Yep, looks great.
Yeah. Hi, everyone. Thanks for joining this presentation. I am Bethel. I am part of the renewables team in the Distributed Systems Group at Pacific Northwest National Laboratory, and I support our energy equity research efforts at the lab. My last name is pronounced Tarakane, for those of you who couldn't do it earlier. I will be presenting today on a few key activities that we are working on the equity topic, including a review paper that we published over the summer that tried to link energy storage and energy equity, and a few other ongoing efforts to advance equity through energy storage system or system solutions. So just to give you a little bit of a context, some of this might be repetitive with Yasmin's presentation, but when we think of energy equity, the common thing that comes to mind would be affordability, which is to say, the energy cost or rates and customers' income to assess whether ratepayers comfortably afford their energy costs. And studies in this space, have shown how these trends are going in the wrong direction, which is to say, as rates increase, and again, this could be due to cost of grid modernization or cost of services, people's income might not have gone up proportionally. So the impacts might be getting worse for some people. But with integrating energy equity as a lens, we get to understand that not all customers have the same needs or face similar impacts. And the impacts are again differentiated by varying demographic factors where one fits, and exactly where one fits within the different segments of society kind of determines the severity of the energy inequities they might be facing. So obviously there is a clear need for doing work on equity to uncover these disparities in how communities experience energy system impacts and how to repair those inequities, either through improving our R&D processes to design technologies to be safer, or through recognizing and modifying the procedural limitations of energy system decision making across the board. So before going into the main part of the work in this paper, I just want to start by providing basic definitions, again, kind of similar to what was presented earlier. The basic theoretical definition that sets, the moral compass, if you will, for equity is the definition that highlights the need to integrate justice principles, fairness, and social equity in energy systems. And again, this is mostly what is used in the academic research space. The other definition is what you see here, energy justice as the goal of achieving equity in both the social and economic participation in the energy system, again, with a focus on historically harmed or historically disadvantaged communities. In looking at equity in the energy transition, another term that is relevant here is the notion of the just transition, and that is defined as, the transition away from the fossil fuel economy, but again, with an emphasis on people and the transition's impact on them, again, from the perspective of, the impact on their livelihood, the decision-making process, and environmental sustainability as well. Going a little bit deeper on the concept of energy justice, the definitions on the left are the components or tenets of energy justice that scholars or practitioners rely on in identifying, inequities or in advancing equity in the energy or in the power system. The first of these is the distributive justice component, which really deals with the question of, who gets what. And in applying the distributive justice component, we try to find where injustices occur to be able to uncover that unequal or unequal allocation of the benefits and burdens of the power system across different segments of societies, just trying to understand, who's getting what from the power system. Recognition is the second of the energy justice tenets, and it is about identifying vulnerable people in relation to the energy system again. So here we are answering the question of who. This component is critical because it allows for innovation or finding targeted solutions for those specifically impacted communities. For example, the impact of the energy system on the chronically ill, the poor, various minorities, and so on will be different from one another. And that will, again, require unique solutions to advance equitable outcomes for each group. Again, critical questions to ask in recognition would be, for example, in times of blackouts, asking the question, who are the vulnerable people whose vulnerability, again, might be worse off due to these outages, right? And this would help us, in making sure those communities are equipped with resiliency capabilities or resiliency mechanisms, such as storage systems, for example. The third component would be procedural justice, which really asks whether there was a fair process in the energy decision making. Again, in promoting equitable outcomes, procedural justice requires fair procedures in every energy plan or rulemaking. That is to say, having a proper information disclosure, having public participation, increasing transparency, enhancing impartiality. All these key due process components need to be factored in. An example here would be, the question of, how interests are weighed in rate making, for example, consumer interest versus the utility interest when the PUC decides on the rates. The last one is the restorative justice component, which really helps us think about how to respond to past inequities and also in proactively thinking about, what inequities to avoid in the future as well. So the other ways scholars have been, trying to make the energy justice component analytically and practically relevant is through these 8 energy justice principles that you see on the top right. I wouldn't define them, but those are one aspect that is being used to define and understand the concepts. Again, another way is looking at the problems or what we call inequities in the power system. The broader inequities we see are shown in the table. And they can include things such as, energy burden, which assesses the percent of a household's income that is spent to cover energy costs. The second inequity is energy insecurity, and this highlights the lived experiences of households facing energy burden and the trade-offs they make in order to meet their basic energy needs. Just to give you a context, in the US, it is reported that 1 in 3 households face some sort of energy insecurity. So there is a significant number of households, who are struggling with these trade-offs quite often already on a day-to-day basis. Another inequity is the issue of energy poverty, which is the lack of access to basic energy. And if we consider, outages due to utility disconnection, here, again, a context in 2015, for example, 17 million households faced energy disconnection notices in the US, and that risk could increase significantly. And we have seen that increase actually during COVID as well. The last is energy vulnerability, again, which focuses on the complex issue of a household's resilience or the capability to be resilient. That is looking at, how the likelihood of a household facing any form of energy inequity and their likelihood to be worse off from it. So if a household was going to face energy insecurity, how would they react back, or how do they respond back to that effect? Again, the main idea, after giving this background, what we wanted to communicate in our paper was to show some of the ways we thought storage fits in that conversation as a solution. So how can it be an asset for equity? In thinking of energy systems designed from a social impact or social equity perspective, the main pathway, at least in our perspective, was to look at the distributed effects. So if we look at affordability, for example, in the US, again, low-income households spend a higher percentage of their income, and that has been mentioned in the previous presentation as well. And actually in research, it has been shown to be 3 times higher than affluent households. And again, this impact gets worsened by systemic inequities across gender, race, ability status, age, housing characteristics, and other dimensions. Again, the current work in this space designates 6% as being high energy burden and 10% of your income being spent on electricity as severe energy burden. And those communities, that are low income and elderly, low income and persons with disability are already almost at the severe energy burden level. So what is the role of storage in this space? The main thing is by scaling and citing storage in social equity terms, it could be deployed to help reduce energy burden for vulnerable people or vulnerable groups facing energy inequity, right? So storage could also enhance, energy security by supporting grid reliability and resilience, by providing backup power in situations of natural disasters or other disruptions in the grid. Again, the main idea is the actual flexibility of storage to be, sited across anywhere on the grid, behind the meter, front of the meter, anywhere. That flexibility could be used intentionally to advance equity for communities. In relation to availability, the main thing is the access to energy technologies across the socioeconomic spectrum. If we take rooftop solar as an example, it has been out of reach for renters and those living in multi-family environments in the past. And the benefit of storage, again, in the availability sense or in increasing access to energy technologies, could be through targeted deployment for households unable to access clean energy technologies or to mitigate inequitable distribution of these benefits. Again, this could be peak shaving or demand charge reduction. All these benefits can be achieved if we take advantage of the locational flexibility of storage and site it within disadvantaged community settings. Another work we did in our equity program was a review of the potential of storage in supporting transitioning communities during power plants decommissioning. This work, for example, looked at 3 power plant decommissioning cases in Oakland, Centralia, and Manatee power plants. And what we learned from these cases was that storage not only allows, a better integration of renewable energy into the grid, but it also assists in the removal of fossil fuels from the grid, while at the same time providing significant local benefits to the community, again, including savings to repairs, emissions reductions, and creating new jobs in the region. Beyond the peaker plant applications, storage might also have a role in supporting post-decommissioning strategies in coal power plant retirements. The map here shows the retired power plants up to 2021 in gray. It might be hard to look for you guys, but the retiring power plants between now and 2024 are shown in red, and the blue shows the retiring plants after 2024. Again, this means that there are still more changes coming that will affect the lives of many communities across the US. So revitalizing and assisting the replacement efforts of coal communities and brownfield locations will need to be envisioned equitably as well. And storage obviously would have a significant role as, as replacement plans and strategies are being rolled out. Storage would be an enabling asset in that sense as well. I wouldn't want to go in detail here on the descriptions, but wanted to put this up here just to show the types of local or community benefits we identified for energy storage, specifically storage and decommissioning strategies. So for example, emissions reduction, especially for frontline and fence line communities, which is really critical in reducing health impacting criteria pollutants for communities living near those power plants. Energy cost reduction and its potential, again, to assist with energy burden, equity enhancement, because again, of the flexibility to locate storage where needed, it can be used as an equity enhancing asset. Increased property value, this might not be a direct benefit, but from studies we saw on rooftop solar, the ability to keep reliable heating and cooling in properties and the ability to decrease energy costs are regarded as positively correlated with housing value. So there could be value in that sense too. Job creation throughout the storage supply chain, less land being needed or less land being used compared to building power plants or transmission lines. And the resilience benefits, obviously, of avoided outages and the costs, due to those disruptions, right? So all of these really make storage a key enabler in advancing energy equity. And this needs to be factored in future evaluation of storage systems as well. To really truly advance, equity, we will need obviously to operationalize it and measure it. It is a relatively newer concept, at least in academia, it might have been available, but at least in the practice or applied sense, I think it has been just active in the past year. So the metrics development is part of the work we are actively trying to pursue. This just shows our initial metrics review work, to see what is out there, what is being used at the moment, what is needed, and see how we might be able to develop an energy equity metrics framework for us to utilize as well. So in our work, we categorized equity metrics into three. One, community descriptive metrics. These are metrics that allow us to identify the target population, which is to say, who is impacted, where are the disadvantaged communities, and so on. The second is the investment distribution metrics. And here we are thinking of metrics we will need to use during investment decision-making processes. So going beyond, return on investment type of thinking. And the last one is more of program results metrics to be able to assess program impact or to measure project success from an equity perspective. So for example, the energy burden index identifies the energy burden facing the target population, whereas the energy burden change metrics at the end will measure the change in the energy burden on that target population identified by examining how that investment or how that project program helped alleviate that burden for that specific group. As we continue this metrics work, these are the areas we identified as immediate opportunities. Mapping and tracking inequities is still first and the most necessary part of the work. We have tools for affordability, but we still need more metrics and more work in tracking inequities across the other dimensions. The scale of equity measurement is another need, which is to say, at what level, societal, community, neighborhood, household, individual level, at what point to measure equity and how to measure it. Again, this is about data availability, are the questions that we are trying to figure out at the moment when it comes to metrics work. We also have a new initiative, the Energy Storage for Social Equity initiative that was launched on September 23. This initiative is a $9 million program aimed at supporting disadvantaged communities with their energy challenges and offers storage as a solution for building, resilience and equity. We are really excited about this effort, and it's in support of the Justice 40 initiative that Yasmin mentioned. And I hope everyone here can maybe, pass on the information to any community that might be eligible to apply to this, because we really want those who need the support most to actually be the ones to take advantage of it as well. Just to give you a little bit of a context or background on the program, the program is structured, or the initiative is structured into phases. In the first phase, we provide non-financial technical assistance to disadvantaged communities, including, performing equity and workforce analysis, energy analysis, economic analysis, and so on, kind of giving them a scope on understanding their energy challenges and providing a solution to their energy challenges along the way. And we aim to offer 10 to 15 TAs for the selected communities. In phase 2, successful TA program participants will be chosen to receive additional engineering assistance for project development and deployment, and our partners over at the Sandia National Laboratories will be leading this effort, and they aim to provide PDDA or project deployment support for up to 6 communities. I just added this here just to highlight where we are with the project. We have finished our initial review panel session in September, and then it was launched, and now we are on full-on, outreach and engagement phase to ensure our target population is aware of the opportunity and to drive applications from eligible applicants, which would close in early December 3rd. And our goal is to have, the participant selection finalized by February and have the TA be pursued in the next year following that. So I'm going to put a link for this initiative, and if you pass it on, it would be really appreciated. So with that, I will conclude my presentation. I want to thank our sponsors, the Department of Energy Office of Electricity Energy Storage Program, for supporting all of this equity work for our program. And thank you everyone for listening to me, and I can pass it on to if there are any questions, or we can take questions at the end too.
Well, let's take one question while we're here. And thanks, Bethel, for that presentation. It was very interesting. We have a question in the chat. Can you speak to the freeze power outage in Texas, where they didn't seem to have a good plan to keep critical consumers such as nursing homes powered? Are you recommending a process for reprioritizing energy distribution through energy storage in cases like this?
Yes, so there are two things in that situation, right? One is how equitable is the designation of critical infrastructure, and whose critical infrastructure or which critical infrastructures are getting the initial, backup power or the initial connection back once outage happens. So there's a lot of equity questions even in the process or in how that designation has happened, like which areas or which communities are we providing power to as, again, like I said, critical versus the other communities. So that by itself is where one of the conversation is going to happen. But the second one is, yes, equipping community centers or health centers, for example, or even when the outage happened, a lot of old age supporting facility centers might be impacted and they might not have gotten power. But if you target those locations for storage and if you provide that backup power, you might be able to mitigate that inequity, at least in some sense, right? But again, that's not the root case. Like the root of the issue is making sure how we distributed the benefits even from the start, right? This might be fixing the problem in some way, but again, that it didn't start when that outage happened and that those communities were impacted, right? So we have to trace it back and ensure that our planning or our distribution system itself is equitably planned from the start.
Excellent, thank you. You gave us a lot to think about. So we'll save some of those other questions for the end, just to make sure that we have time for our next speaker. Morgan Smith, go ahead.
Thank you, Alex. I'm going to go ahead and pull up my screen here.
We see it.
Okay, perfect. So thanks everybody for the great presentations before me, Yasmin and Bethel. I'm going to take this in a slightly different direction and talk about the leading climate solution hiding in your local supermarket. So today we'll be covering HFC refrigerants in supermarkets, some regulatory trends that are impacting that, and some solutions and opportunities to accelerate the transition to climate-friendly solutions. So Alex gave a great presentation introduction at the start of this session. You've all probably been waiting at the edge of your seat for what NASRC stands for. It stands for the North American Sustainable Refrigeration Council. It's a long name, with a very simple mission. So all of our work is centered around advancing climate-friendly natural refrigerants, including carbon dioxide, hydrocarbons, and ammonia in supermarket refrigeration. And I'll talk more about why that is so important. But just to take a quick step back, the reason that we focus on sustainable refrigeration is because this was named the leading solution to climate change by Project Drawdown back in 2017. And I'm sure many of you are familiar with Project Drawdown, but for those who are not, it listed the top 100 science-backed solutions to reverse global warming. And the reason that this is such an impactful climate topic is because commonly used refrigerants, hydrofluorocarbons or HFCs, I'll reference them a lot in this presentation, are extremely potent greenhouse gases that pound for pound trap thousands of times more heat in the atmosphere than CO2. And due to the increased demand for cooling globally, they're growing faster than any other greenhouse gas on the planet. So because of this, scientists have estimated that eliminating HFCs could avoid up to 0.5 degrees of warming by the end of the century. And when we look at where these emissions of HFCs are coming from, we have to look at grocery stores. So if you look at a home refrigerator, it probably has less than 10 pounds of refrigerant, and it's all sealed into one hermetically sealed piece of equipment. And so it's probably not leaking at all. If it is, it's certainly going to be a very low leak rate, less than 1%. And the reason that leaks are so important here is because leaks are how these refrigerants get into the atmosphere. If they stayed cycling throughout a refrigeration system, they wouldn't be a problem for the climate. By comparison, if you look at a grocery store refrigeration system, it's very large and very complex. And so there's miles of piping and thousands of valves and connection points in a single grocery refrigeration system. And it's carrying that refrigerant all throughout the store. And what that means is that these systems are inherently leaky because there's so many opportunities for leaks. So on average, in the US, each supermarket leaks about 25% of its total refrigerant load every year. And this is extremely important because on average, a grocery store will have 3,500 to 4,000 pounds of refrigerant in their system. So we're looking at somewhere between 850 and 1,000 pounds of these really potent greenhouse gases being leaked into the atmosphere every year in a single grocery store. So what does that equate to? Well, if we look at one of the commonly used refrigerants called 404A, and we were to apply that across the average amounts that I just went over, we'd be looking at about 3.4 million pounds of CO2 annually, CO2e annually, emitted from a single grocery refrigeration system. And that's what we would call the direct emissions. So it's the direct emissions of the refrigerant. But this session today is all about decarbonization. And so energy is also a really important piece of this. And grocery stores have one of the highest energy use intensities of any building type. So that's also really important to consider here. And if you look at the indirect emissions of a refrigeration system from energy use, we estimate that it's around 3 million pounds of CO2e annually as well. So I do want to call out that if we compare the emissions from annual energy use versus the emissions from refrigerants, it's actually higher from the refrigerant leaks, but it's very significant if you combine these things together. And that's what we call TWE, or the total equivalent warming impact. And that's an important metric to consider when you're looking at total decarbonization in grocery stores. It's the indirect emissions plus the direct emissions. So that's just for one store. But if we multiply the direct emissions of the leaks by all of the stores in the US, we get a total direct emissions of about 70 million metric tons of CO2 equivalent just from leaks. And that's equivalent to roughly the annual electricity used by 12 million households, or nearly all of the households in the state of California in just a year. And because HFC emissions are growing, other sources of emissions are also projected to shrink. Those things combined, we expect HFCs to become a bigger portion of the total greenhouse gas emissions, growing from where it is today, around 2%, to up to 15% or more over the next 10 years. So for all of these reasons, HFCs are becoming a more important part of climate policies at the state and federal level. The US recently enacted the American Innovation and Manufacturing Act, or the AIM Act, and that will phase down the production and consumption of HFCs by 85% over the next 15 years in the US. The act also authorizes the EPA to implement other strategies to establish restrictions on certain refrigerants and to implement requirements for refrigerant management around servicing the equipment. But I'm going to focus on the phase down right now because that part of the regulation has already been released. And this isn't the first time that we've seen refrigerants phase out. So many of you are probably familiar with the phase out of CFCs under the Montreal Protocol due to the impact that they had on the ozone layer. So from there, the industry moved to HCFCs, which were then phased out. And now under the AIM Act, we're phasing out HFCs. And so we're kind of seeing this continuous step down where we transition to a new refrigerant, and you know, as soon as you think you're through it, you have to transition again. So we would like to see an end to this continuous phase out of refrigerants and jump all the way to the future-proof option at the bottom, which is primarily natural refrigerants. And really, this is a future-proof option. So not only is this the most climate-friendly option, but it is also future-proof from a regulatory perspective. So it's good for the industry. But one of the challenges is that they are not what we call a drop-in solution. So they require a full system replacement, which is costly and challenging, especially for smaller grocers, which I'll talk about in a few minutes. But just to give you a sense of the refrigerant options that are currently available, the y-axis here is the global warming potential, or GWP. And that's a measure of how much heat a greenhouse gas traps in the atmosphere compared to CO2. So the refrigerants on the right are the high GWP refrigerants that are commonly in use now. These refrigerants in the middle are the medium GWP refrigerants, which are drop-in solutions. But then all the way on the left are the natural refrigerants, ammonia, CO2, and hydrocarbons. So you can see the climate impact is drastically lower. And that's why we want to get all the way to these zero impact refrigerants and not stop at this middle level here. And unfortunately, with the phase down schedule, we won't get there fast enough with the current regulations. So just to quickly run through this red line at the top represents the baseline that we're at right now. And the blue line represents the phase out of HFC refrigerants over the next 15 years. This yellow line in the middle would be if we were to get to all of the stores using those medium GWP refrigerants that I mentioned. And then this green line all the way at the bottom is natural refrigerants. So if you look all the way to the right, you can see there's a gap between where the blue line ends and the green line. And so the regulations alone are not going to get us there. And that's because there's a number of challenges that are associated with these refrigerants. So our theory of change at the NASRC is really to address this negative feedback loop that we've seen. And this is really common with a lot of new technologies. So you have this low volume of adoption, which means you haven't reached economies of scale. So there's extremely high upfront cost premiums. There's also some gaps in technology availability and some challenges with availability of data on the performance of these technologies, which I'll talk more about, and then challenges with the service workforce. In the commercial refrigeration industry, the service workforce is aging out and we don't have young blood coming in. And then that coupled with the low volume of demand, these service contractors that are already stretched very thin don't have the bandwidth to invest in training on these new refrigeration technologies. And so there's a number of solutions that can help contribute to turning this negative feedback loop into a positive one. So starting in the top left here, having effective policies that do accelerate adoption. And so we are on our way there with the AIM Act, but as I mentioned, it won't get us all the way. But other resources for brochures around case studies, best practices, knowledge sharing. For upfront cost premiums, there's really a need for incentives to offset that first cost to drive the early adoption of these technologies and ultimately reach economies of scale. For lack of technologies, there's a need for pilot projects and performance studies, updates to codes and standards, and also market signaling. So understanding which technologies will actually fulfill the needs here. And then finally, for workforce development, I know Yasmin mentioned this in her great presentation, that this is a focus of the administration right now. And it's a huge focus for us as well. So how do we build up the service workforce and increase training resources so that suddenly we have a high volume of demand, low upfront cost or cost parity, adequate technologies, and a robust service workforce who is qualified to work on these technologies. Just a couple of considerations I want to go through here as well. The greatest opportunity and the greatest challenge is really with the 38,000 existing grocery stores in the US. So there's very few new stores being built. And for the larger chains, natural refrigerants are starting to become standard because they have more resources. So really the opportunity is with this existing stock of stores, which is where we're seeing the emissions of HFC refrigerants. And this is where we're starting to see some of those medium GWP HFO blends become standard. But what I really want to call out, especially because this is a decarbonization session, is if we go back to that term that I mentioned, TIWI, because there's a risk of, if you only focus on the refrigerant itself, there's a risk of decreasing your emissions from your refrigerant by transitioning to a climate-friendly refrigerant and increasing your emissions from energy use if you don't optimize your system for energy performance. And so you end up with this situation where the decarbonization trends are in collision, and you're not achieving the lowest possible carbon footprint. So really the ultimate goal here is to drive both down and achieve the lowest possible carbon footprint, by reducing both direct and indirect emissions. And really the biggest challenge here is going to be supporting the small and independent grocers, because they will be the ones who are disproportionately impacted by the regulation. And this is hugely important because oftentimes these are the grocers that are serving disadvantaged communities. And in many cases, they're the only grocery store within their community. But they don't have the resources to keep up with this for a number of reasons. They often don't have many stores to help scale some of their changes. They rely on used equipment in many cases. They don't have a facility staff. So if you look at some of these larger chains, you have a whole team of folks that are focused on utilities and engineering. And in a small independent grocery store, the same person who's stocking the shelves and coming up with the business hours is also responsible for the refrigeration equipment. Additionally, due to lack of resources, they don't have a lot of access to engineering or maintenance services, which helps to optimize the performance of the system. And as a result, they're often unable to afford the transition. So just to break this down at a very high level, there is an opportunity to intervene now as grocers are starting to evaluate what they're going to do under the new regulations. So if we look at sort of the pathway of decisions for impacts to existing stores, particularly from the perspective of a small grocer, starting with refrigerant regulations, there's a risk that the small independents will not be able to afford the transition, and we have store closures. And that's really the biggest risk here, because then you risk things like food deserts. You take away one of the biggest employers in communities, often. It's a huge challenge. But the opportunity here is to support grocers that are specifically located in disadvantaged communities through some of the interventions that I mentioned earlier. When you look at the refrigerant choice, there's a risk that these grocers will transition just to those drop-in medium GWP refrigerants, which means they'll probably face another phase out in the future, which could bring us back up to the risk in number one here. But from a climate perspective, we're not achieving the greatest emissions reduction that we could. So the opportunity is to transition all the way to zero. From an energy performance standard, this is what I mentioned before, there's a risk of increasing energy use. And so there's an opportunity to support system design and make sure that they're optimized for energy efficiency. And then as a result, hopefully, we don't leave emission reduction potential on the table. We achieve the lowest carbon footprint possible, and we end up with future-proof solutions. So I'm going to buzz through this slide in the interest of time, but really, if we're looking at this from a community level, which I think many of the folks on the line are working at that level, there's a need for holistic solutions to make that happen. So these are just a couple of examples of the types of work that we've seen make an impact at a community level, starting with a community HFC inventory, from there evaluating the alternative options and educating the small grocers within their community on what their options are, and then connecting and implementing these solutions with a number of partners. And this slide is really just meant to demonstrate the vast breadth of stakeholders who could play a role in these solutions, and some of the different ideas that we've helped other communities with. So I'm happy to discuss this in more detail with anyone who's interested in implementing a program like this. So that was a lot of information. And so if you take nothing else away from this presentation, the key takeaways are that hydrofluorocarbons are some of the most potent greenhouse gases in existence. Natural refrigerants are a future-proof solution, but there's still many challenges. That new regulations will phase down HFCs, but the regulations will have a disproportionate impact on independent grocers, and that there's a need for on-the-ground solutions to accelerate the transition and maximize emissions reduction while addressing the challenges to small independents specifically. I believe these slides will be made available to you, so we have a number of resources that I encourage you to check out, and please feel free to reach out to me at any time. And with that, I will stop for questions.
Awesome, thank you. Having worked in the energy industry in the past, the work you're doing is very important, so I'm glad to see it. We do have some questions. Do you also work with industry and manufacturers that are still using HFCs at their plants for HVAC uses?
Yes, we do. So we're supported actually by a network of over 140 industry stakeholders. They're all involved in our initiatives. We work in partnership with them for our solutions because we've found that that's the best way to implement on the ground actions. So happy to share a list of who's involved with whoever asked that question.
Excellent, thank you. And a couple minutes left, but could you talk about the types of industry case studies you're looking for? Do you have a network of providers that could test these technologies nationally?
Yeah, so primarily we're looking for installations of innovative technology types, which is kind of a caveat or a catch-all response, but really what that means is we're trying to understand some of the new energy saving design features and how they could impact energy performance, because many of them have never been installed because they're new technologies. And then I think the biggest need is to understand and look at case studies of where grocers have been able to start to modularly transition an existing store over, because for a small grocer that doesn't have a lot of resources, that slow migration of their system over to a natural refrigerant is going to be much more economically viable for them. And then in terms of providers that could test the technologies nationally, we work in partnership with a number of utilities and national labs primarily, but we have a lot of partners that participate in our pilot program.
Excellent, thanks. Since we are running out of time here, we've just got a few seconds left. I do want to point out that there is a survey there in the chat, if folks could make sure to do that. And I want to thank Yasmin, Bethel, and Morgan for their presentations today. You did a great job and presented a lot of really interesting information. The next time we're all going to get together is next week on October 27th. So thanks again, presenters, and we'll see everybody next time.